The GATE 2024 aspirants. So just about a month left for the examination. So trying to cover up some important areas, and I was looking into the students' mindset, and the demand coming up was complex variables. This time from engineering mathematics, many students felt that it is definitely it's an important topic. Okay, so this session is planned to cover up all the important categories, all the important points that come up from the function of complex variable, be it the questions from analytic function, be it the questions from Cauchy-Riemann equations, be it the question related to harmonic functions, be it the question related to integral of complex, contour integral of complex function. I think that's a very, very important part. The contour integral of complex functions. So all those things will be covered up in this particular session. It's going to be a complete review of all in things that you need to learn. Yes, Mahendra. But the only difference is, since we just have 1 month left for the examination, so we will not focus much on derivation and all, and anyways you don't need also, but all important variety of questions, with their approach, with the required theory, everything will be there for you. That means even if you have not studied anything about the complex variable right now, you can attend the session. Anything regarding to the functions of complex variable. All right, guys, to quickly update all your friends that the session is live. Yes, very, very good morning. Good morning, Ashok. Good morning, Mahendra. Good morning, Museb. Good morning, Mindu. Good morning, Lokesh. Very good morning, all. Quickly update all your friends, and then let's get started immediately. All right. Just a moment. Ji. Chalo. So yeah, good morning, Bhanu Prakash. Good morning, Shashwat. Good morning, Nitin. Good morning, Gautam. Gautam, we can plan for algebra as well. Me. Chalo guys, so time to get moving ahead. So engineering services results were out some time back, and yes, BYJU'S exam prep students have really outshined. All India rank 1, all India rank 9. Not only this, around 5 aspirants under rank 10, and 37 aspirants under rank 100. Big achievements, and hope you also keep your preparation full swing, and appear in this GATE or ESE results up to next year. Now guys, let's get started quickly. Functions of complex variable. Functions of complex variable. 100% me, Venkat, for EC in engineering maths, you have almost surety that you're going to get a question from complex variables. And especially the integral part, especially the contour integral part, us pe bhi aayenge. Good morning, Darshan. Good morning, Chaitanya. Ashok, we can discuss that at the end. Just put that doubt in the end. So guys, we all know that Z is a complex variable represented as x plus iy, or if you want, you can also represent Z is equal to R e power I theta. R e power I theta. We can represent the complex number either in the Euler form, or either in the Cartesian form. Z is equal to x plus iy. This is known as the Cartesian form, and R e power I theta is the Euler form. Acha ji, what is the R? We all know that. What is the magnitude of complex number? Under root x square plus y square, and theta, argument of complex number, tan inverse y by x. Of course, we directly start with the function of complex variable, not the basics of complex number like magnitude, phase, angle, all that you must be knowing. Chalo, so now, when Z itself is a complex variable, say for example, you take any function of Z, when you take any function of Z, suppose fz that is equal to z square, and substitute Z is equal to, say, Cartesian form x plus iy, x plus iy whole square, and expand a plus b whole square, so you get a square plus b square plus 2ab. So this function now looks like, what is the value of I square, everybody? The value of I square will be the -1, so this can now be written as x square minus of y square. I square is -1, so this is completely real. Plus I 2xy. So, since the function is the function of a complex variable, what is the answer you get itself will be complex. Having some real part, which I'm going to call it as u, having some imaginary part, which I'm going to call it as v. Okay, so fz can be expressed as u plus iv. It can be expressed as u plus iv, where u will be real part of the function, v will be the imaginary part of the function. Okay, acha. There are some functions, for example, which are very common and which are very relevant for questions also. Suppose I take a logarithm function. Suppose fz is equal to log z. Suppose that the fz is equal to log z. Okay, like z square, a square function, I put z equal to x plus iy and expanded and got what is the real part and what is the imaginary part. यहाँ पे देखेंगे, if fz is log z, okay, to simplify log z, what is the real part and what is the imaginary part? Okay, I will put down z in the Euler form. The simple reason is we know the identity for log of a into b. We know the identity for log of a into b, but not log a plus b. Okay, log a plus b cannot be expanded, but log a into b. That is why I don't put x plus iy, I put the Euler form. Complex number can be put in any form. Na? Now you can break this, dear. Log a into b is log a plus log b. Okay, log and exponential are inverse of each other. Okay, so they would cancel. Power comes outside. The power is I theta, that is outside, and log and exponential, the value of log e will be 1 basically. Okay, so now we have got the real and imaginary part. Let us put it in x and y format. Okay, so what is the function now? Dear, it is turning out to be log r. What is r? We know in terms of x and y. Under root x square plus y square plus I theta. What is theta? What is the face of the complex number? Tan inverse y by x. Now we can call that. This is known as u, this is known as the v. This is known as u, this is known as the v. Okay. Acha ji. Now, there is one interesting thing that comes up from here. Okay. Till now, when you are in the real world domain, you say that log of negative numbers cannot be defined. Okay. Log of negative numbers cannot be defined. So, if I ask you, dear, what is the value of log minus 3? Can you tell me this value? Log of negative numbers in the real domain is not defined actually. There is no real solution to it. Okay, definitely I can say that this particular problem has no real solution. 100%. No real solution. Log of negative numbers is not defined. But if you take up the idea from the complex domain, okay, oh, you see, what is minus 3? Now, you can try to put minus 3, okay, as minus 3 plus I0, okay, minus 3 plus I0. Okay, now what is the magnitude? R means modulus of Z. Now what is the magnitude of Z? Okay, isko Z मान लेते हैं. Let Z equal to minus 3. So magnitude is 3. What about the theta? Dear, this number is the minus 3. Na? Where will the minus 3? Minus 3 means purely real but negative. Purely real means negative. This is the value of Z. Okay, so what is the face of this number? You can calculate by formula also, or you can see directly. What is the face of this number, dear? What is the face of this number? The face, the argument of any complex number is measured with respect to the positive x-axis, na? Okay, so from the positive x-axis, you take how much degree? You take 180 degree to reach the negative real axis. 180 degree or pi. Okay, because I have taken anti-clockwise angle, always remember, dear, anti-clockwise angle means positive, clockwise angle means negative. Okay. So what is the theta? It can be written as pi. ठीक है जी. So this z can now be written in the Euler form. It can be written as 3 e power I pi. R e power I theta na. So 3 e power I theta. ठीक है. Now what is the log of z? Okay. What is the log of z? As I just explained you, it is log r plus I theta. Okay. It is known as log r plus I theta. Okay, so log of z, that means if I want to calculate log of minus 3, it becomes log of 3, r is part, the magnitude part is 3 plus I pi. So it has a complex solution. Log of negative numbers can be defined, but that solution will be complex in nature, and that log of minus 3 will be log 3 plus I pi. Log 3 plus I pi. Okay, so not only this, remember, in general, when you want to define log of any negative number, log of minus k, that can be written as log of k plus or minus I pi. Okay. The plus or why plus minus both? Dekho na. I measured the angle anti-clockwise. Suppose you say angle is with respect to positive x-axis. That is what we are known. But somebody travels here. Somebody travels from here. That is minus 180 degree, because this is also one semicircle, 180 degree. But if you travel clockwise angles always put a minus sign. For the clockwise angle, always put a minus sign. So that will be minus 180 degree. Okay? That will be known as minus 180 degree. ठीक है जी, चलो डन है, कूल है. So let's move ahead. Okay, so log of negative numbers can also be defined. Log of negative numbers can also be defined. This is the idea to define log of negative numbers. ठीक है, चलो. Good morning Hari, good morning Sagnika, good morning Biren. Have a look into it. For the function of complex variable w equal to log z, a question on the log z function, okay, where w is equal to u plus iv and z is equal to x plus iy, the u equal to constant lines get mapped in the z plane as how? The u equal to constant lines are mapped as, okay, the u equal to constant lines get mapped. Mapped means the plot. How will you plot u equal to constant line? So dear, what is u equal to constant? So we have done the analysis of log z, na? We have done the analysis of log z. Okay, I need u equal to constant, and in the log z dear, and in the log z, what is the value for u? U was equal to log r, v was equal to the theta, log r plus I theta. Okay, good morning, namaste Ananta. So when I say u, it means log r, the log r equal to constant. Okay, some constant c. So what is the r? It is e raised to the power c. Okay, c is a constant, so e power c is also some constant, suppose k. But what is r? Square root x square plus y square equal to k. Square root of x square plus y square equal to k. So what is x square plus y square? What is x square plus y square? Okay, that is k square. And what is this equation corresponding to? I mean, when you try to plot u equal to constant, when you map it in the z plane, when you draw the plot, it is looking like x square plus y square equal to k square. We all know it is the equation of circle. Okay, so there will be set of concentric circles. Why do I call it a set of concentric circles? Okay, x square plus y square equal to k square. The center is fixed, 0, 0. But the radius of the circle, see, this is the radius. X square plus y square equal to r square. Radius depends on whatever constant value given. Okay, the radius can vary as per the data in the question, but circle is fixed. A center is fixed. Okay, so you may have a circle of unit radius. This is origin, suppose, or radius 2 or radius 3. But all of the circles will have a common center. And that is what is known as set of concentric circles. That is what you know as the set of concentric circles, na? Option number B, very clearly. Okay? Option number B. Acha, by chance if I ask you, what will be the mapping of, V equal to constant? Then can you tell me, what will be the mapping of V equal to constant? And guys, I just need to bring something. Just allow me a 1 minute and please complete this by the time. Yes, dear. Hope so. That is now done. Okay, straight lines are now coming up. So guys, now we know we are talking about log z function. So what is the value for v? Okay, what is the value for v? Now we know that v is the tan inverse y by x, and that is constant. Okay, so y by x equal to tan of constant. C is constant, or tan constant is tan of c is also some constant. Suppose k, y by x equal to k, so y equal to kx. Okay, these are straight lines. Actually, the option that will correspond here is the option number A, set of radial straight lines. Now, what are radial straight lines? See, y equal to mx. Y equal to mx, line passing through origin. Okay, y equal to mx simply means line passing through origin. Okay, but the slope depends on the given constant. Okay, the slope can vary as per the data in the question. Okay, but all of the line are passing through origin. All of the lines are passing through origin. Okay, so set of lines passing through a common point. Set of lines passing through a common point. That is what is, okay, radial straight lines. Okay, radial straight lines. Okay, here the set of lines passing through origin. So it will correspond to option number A. Okay, that will correspond to option number A. In that case, if the question was V. Okay. Chalo. So there are some basic questions on functions before we start analytic functions. Actually, the first important topic starts with analytic function, but there are some basic questions here. Okay, let's have a look into one more. Let S be the set of points in the complex plane corresponding to the unit circle. Okay, let S be the set of points in the complex plane corresponding to unit circle. Okay, now how do we define unit circle? See, in the complex plane, dear, whenever you write down mod z equal to r, that is a circle, na? That is a circle, because mod z, magnitude of z is root over x square plus y square, and if you take mod z equal to constant r, under root x square plus y square equal to r, okay, so x square plus y square equal to r square. So mod z equal to r is the equation of a circle. Okay, with what center? Center at 0, 0, and r is the radius. Okay, ये सब contour integral में भी use होगा. This is a circle with the center 0, 0, okay, and radius equal to r. Okay, on the other hand, if you take the equation of the form modulus of z minus z not equal to r, modulus of z minus z not equal to r, that is the equation of circle, okay, having the center as z naught, having the center as z naught. Okay, okay, so basic parameters you must know. Now question में क्या बोला है? Let S be the set of points in the complex plane corresponding to the unit circle. That is mod z equal to 1. Unit circle means radius equal to 1. Okay. Consider the function fz is equal to z star, where z star is the complex conjugate of z. Okay. The fz maps S to which one of the following in the complex plane? The fz maps S. S is mod set of all the points in the complex plane corresponding to your unit circle. So what is fz? Let us understand here. Only thing that is important in such question is the language. क्या बोला है? fz. Let us talk about the function fz. What is the function fz? That is z star. Okay, that is z star. But what is z star? What is z star? Okay, dear, when you multiply any complex variable by its conjugate, what do you get? What do you get? Anybody? See, z is x plus iy. Its conjugate is known as, what is the conjugate of a complex number? X minus iy. Okay. Now, a plus b, a minus b. That is a square minus b square. But I square is minus 1. So minus minus plus ho jayega basically. This is always mod z square. That is always mod z square. Okay. So f of z, okay dear, which is z into z star, that is mod z square. That is mod z square. This is the given function. Now क्या बोला है? The given function fz maps S. What is S? Okay, S corresponds to set of all the points which lie on the unit circle. Okay, set of all the points which lie on the unit circle. Mod z equal to 1. So corresponding to these set of points, dear. Okay, what is the fz? Okay, fz is mod z square, but mod z is 1. Corresponding to these set of points, mod z is 1. So fz equal to 1. Okay, fz equal to 1. So now what is the correct option? Is it unit circle? No, it's not the option number A, Ashok. Okay, fz, the value that you obtain is simply 1. What is 1? 1 is like 1 plus I0. 1 plus I0. Okay, it is basically the point 1 comma 0. I mean, how do you draw 1 plus I0? Like x plus iy, how do you plot x comma y? So it is simply 1 plus I0, or that is 1 plus 0, 1 comma 0. Okay. ठीक है, चलो done. Yeah, correct answer is C now. Correct Sagnika, Prakhar, Ashok. Chalo, let's move ahead. Okay, and let us also get started with the analytic function. So some discussions on basics function. Okay, some basic questions you can expect on functions. Okay, now analytic functions. Okay, somehow related to derivative of function. But when I talk about the derivative, okay, the differentiation of a function, the basic principle is same as the first principle. Okay, like y equal to fx. How do you define? Okay, if y equal to fx in the real domain, what is dy by dx? Okay, it is defined as change in the function f of x plus h minus f of x divided by change in x, that is equal to h, where the change should be small. Limit of h tending to 0. Limit of h tending to 0. Okay, so if w is equal to fz, okay, dw by dz, or simply f dash z, is defined as limit delta z tending to 0, f of z plus delta z minus fz upon delta z. Okay, yeah, delta z is like z plus delta z minus z. So I change z from z to z plus delta z. The change in function is known as fz, and the final value is f of z plus delta z. So change is final minus initial. Okay, so same first principle that you apply in the basic calculus has been used here. Okay, has been used here. Okay. Now, to understand, exactly what analytic function is and how it is, what is a differentiable function and what is an analytic function. Is there any difference? Okay, I can say that a function is differentiable at a point z equal to z naught. On the other side, I say that a function is analytic at z equal to z naught. Is there any difference in these two? Listen to the two statements. A function is differentiable at a point z equal to z naught. A function is analytic at a point z equal to z naught. What is the difference in these two? To understand the difference, just ignore this right now. I will come back to it. Okay, I will come back to it. Okay, but let us talk about the CR equation. It's not only कि complex के लिए analytic name use करते हैं. There is some fundamental conceptual difference. I will try to highlight that. Okay, then we will go through all these points backward. Okay, forget this. Okay. The necessary and sufficient condition for a function fz equal to u plus iv to be analytic are, okay, the del u by del x, del u by del y, del v by del x, del v by del y. All the first derivatives or u and v, okay, must be continuous functions. And here comes the very, very important part. Okay, that is the Cauchy-Riemann equations. The very, very important part, that is the Cauchy-Riemann equations. Okay, very important part here. Okay, the del u by del x should be equal to del v by del y, and del u by del y should be minus del v by del x. Okay, you can also write it as u of x equal to v of y. Okay, partial derivative notation. And del u by del y, that is differentiation of u partially with y, is minus del v by del x, that is minus of vx. Okay. Now, let us apply this to a problem. Okay, and then we'll go back reverse and see the theory. Polar form में Cauchy-Riemann equation we'll see later. Now, let's take an example here, dear. Okay, consider the function fz is equal to x square plus iy cube. Consider the function x square plus iy cube. Okay, and choose the correct option. Okay, is it analytic everywhere? Is it analytic everywhere except origin, or not analytic anywhere, or not analytic everywhere except 0, 0? What is the true condition regarding to it? So we can say that, okay, the x square corresponds to the real part u, y cube corresponds to the imaginary part v. Okay? Now, for the function to be analytic, it must satisfy the CR equation. For the function to be analytic, it must satisfy the Cauchy-Riemann equation. We'll simply call it as CR equations in short. Okay, and let us satisfy the CR equation here. Okay, what is u is x square. Okay, and what is v is equal to y cube. Correct? Okay, so what is ux? Okay, del u by del x. Ux means del u by del x, and that is 2x. पहले सारे partial derivative लिख लेते हैं. What is uy? That is del u by del y, and del u by del y. U is a function of x only. The differentiation with y will be 0. Okay, next, what is vx? Vx means del v by del x. Del v by del x will be 0. Del v by del x will be 0 because you are partially differentiating with x and it is a function of y. Vy, del v by del y, differentiation with y. So y cube differentiation is known as 3y square. Okay. Now, these are the results calculated on u and v. Now let me apply the CR equations. Now let us apply the Cauchy-Riemann equation. Okay, according to the Cauchy-Riemann equation, okay, number one, ux should be equal to vy, and number two, okay, uy should be minus vx. यही देखा था ना? Uy should be minus vx. But if you see here, uy and vx both are 0. So this is automatically satisfied. Okay, ये तो automatically satisfied है. We'll talk about this one. What is ux? 2x. And what is vy? 3y square. Now you have this condition 2x equal to 3y square, or you can say that y square equal to 2 by 3x. Y square equal to 4ax type equation. Okay, this corresponds to a plot. This corresponds to a plot. And what is that plot equal to? What is that plot equal to? It's a parabolic. Y square equal to 4ax, parabola opening to the right. Now, can I say that the function is analytic at all the points on this parabola? Because second CR equation is always satisfied. This is always satisfied. First, for the first CR equation to satisfy, I am getting the relation y square equal to 2 by 3x. Okay, and hence it is a parabola. Hence it is a parabola. I can say that the function is analytic at every point on the parabola. No. Understand the difference. I was trying to explain you a difference. What is a differentiable function? What is an analytic function? Dear, if I take any point on the curve, function is differentiable. Okay. At any point on this curve, y square equal to 2 by 3x, function is differentiable. Okay. Now, if I take any other point, any point in the neighborhood of this point, इस point के neighborhood पे, suppose I take here, please try to see it very carefully. If I take it here, very close to the first point, but not on the parabola. Okay, so the function is not differentiable here. Function can be differentiable only on this parabolic path. Okay, so I can say that function is differentiable at a point, but is it differentiable in all the neighborhood points also? Neighborhood point से मेरा क्या मतलब है? See, I am trying to tell you that a function may be differentiable at this point. A function may be differentiable at this point, but is it differentiable in all the surrounding neighborhood points? Neighborhood means very close. I don't say कि ये वाला point और ये वाला point होना चाहिए, but neighborhood means very close points. If a function is differentiable here and it is also differentiable in all the neighborhood points, then it is said to be analytic. Okay. This particular function will actually not be analytic anywhere. Whenever you get that, CR equation satisfies on a single path. Okay, the function is differentiable on the path, but as soon as you deviate, even a single inch, if you deviate from the path, okay, the function is not differentiable there, means not analytic. That is what I was trying to explain you here. यहाँ पे आना पहले. If a function is differentiable at some point z0 and also differentiable in the neighborhood of z0, okay, it should be differentiable at the point z0 and also differentiable in the neighborhood of z0, then it is said to be analytic, dear. Then it is said to be analytic at the point z0. Okay, hope you are getting the idea. Okay, hope you are getting the idea. Okay, hope you are getting the idea. Okay, so then it is said to be analytic at the point z0. अच्छा, now let me take another example here. ठीक है, थोड़ा सा और लेके चलते हैं. Let me take another example here, then we'll come back. Okay, so now let's take an example here. Suppose fz is equal to z square. Okay, fz is equal to z square. Okay, so what is the expansion of z square? Already we have learned, na? X square minus y square plus I 2xy. Let us write this in the u plus iv format. Let us write this in the u plus iv format. Okay, what is the value of u? X square minus y square. What is the value of v? Is 2xy. Okay, now what is the value of ux? Differentiation with x, 2x. What is uy? Partial derivative with y, minus 2y. ठीक है. What is the value of uy? Sorry, ये है v. What is the value of Vx? Differentiation with x, 2y. Okay, what is the differentiation with y? Vy. Okay, 2x. Now please see. Okay, for the CR equation to be satisfied, what is the first CR equation? Ux equal to Vy. Conditionally differentiable again, Ananta. Okay? Ux equal to Vy. Is it always true? 2x is always 2x. Here you don't get a particular path. Right? 2x is always equal to 2x na? For any value of x. So this is always true. Second, what is the second one you need? Uy equal to minus Vx. Uy minus 2y and Vx is 2y. So minus Vx is minus 2y. This also always matches. Because I need minus Vx, okay? So minus 2y, for any value of y, minus 2y is minus 2y. So they always match. CR equation satisfied for all xy. I can say that here, CR equation is satisfied for all values of xy. Yes or no? For all values of xy, it is satisfied. Okay, so the function fz, I can say that the function fz is analytic everywhere. Is analytic always. It is analytic everywhere in the z plane. Acha. Ab dekho, try to connect some of the thing with the basic calculus also. See, the basic principle of differentiation is same as what we define in the calculus also. This is how we define dy by dx. Same way we have defined dw by dz, where w is a function of complex variable. So some basic rules of differentiation, okay, from the real world calculus will be the same. For example, there are some common functions, okay, that you call it as the polynomial functions, like z square, z cube, z power 4. All these are what? All these are polynomial functions. And what do you learn for polynomial functions in the real world also? They are always differentiable. Here also, abhi maine kya prove kiya? That z square is always analytic. It is always differentiable, always analytic everywhere in the z plane. Okay. So similarly, not only polynomial functions, okay, the regular functions that you study in calculus, sinusoids, exponential function, they are always differentiable. Okay, I'll say they are always analytic. Now, if a function is analytic at all points in a complex plane, if a function is analytic everywhere in the complex plane, then it is also said to be entire function. Some languages, such languages can come, so you should know what is the meaning of entire function. If a function is analytic at all points in the complex plane, then it is said to be entire function. Now, analytic functions are also known as regular functions or holomorphic functions, but commonly analytic function word hi aayega, but you must know these words. Okay, so polynomial function, sine, cos, exponential function, they are entire function, analytic everywhere. Okay, now there will be some set of points. Say for example, if you take the function fz is equal to sec z, or sec z is 1 upon cos z. Okay, 1 upon cos z. Okay, what is the value of cos z at z equal to pi by 2? If you put z equal to pi by 2, dear, okay, cos pi by 2 is 0. 1 upon 0, infinity, the function itself is undefined. If a function is not defined, it cannot be differentiable. Right? Na? If a function is not defined, it cannot be differentiable at the point. So I can say that pi by 2 or even 3 pi by 2, 5 pi by 2, these are the points at which this particular function is not analytic. The set of points at which the function is not analytic, okay, are known as the singular points. Okay, the set of points where the function is not analytic are known as the singular points. Okay, they are known as the singular points. Okay, they are known as the singular points. Then we have learned the CR equations. Okay, for a function to be analytic, all the first derivatives of u and v must be continuous function, and more importantly, you must remember this for numerical point of view, it should satisfy the CR equation, ux equal to vy and uy equal to minus vx. Suppose the function is in the polar form, r theta form, like we took for log z. Okay, then what is the Cauchy-Riemann equation in polar form? Okay, it is given by del u by del r. Okay, that is ur. Okay, is 1 by r v theta, del v by del theta. Okay, okay. Then what is del u by del theta? Okay, u theta is equal to minus r del V by del R, that is VR. Okay. Acha, thank you, Raj. ठीक है, चलो. Okay, so these are the Cauchy-Riemann equation in the polar form. I told you derive नहीं करेंगे आज कुछ भी. Okay, so del U by del R is 1 by R del V by del theta. Del U by del theta is minus R del V by del R. ठीक है. That is what is the Cauchy-Riemann equation in the polar form. Done hai. Now, look into next question. I give you two functions. Fz is equal to z square. Okay. And f2z is z bar, where z bar is the conjugate, like z star. Okay. Dear, what is the first function? Okay. Fz is equal to z square. Okay. Now, z square already proved, na? Z square is already proved. Okay. It is analytic. Just now we discussed this question, na? This is analytic. What about f2z? What about f2z? That is given as z bar. That is z star. Okay. Is this also analytic? Okay. When I don't specify any region, means I want the function is analytic everywhere. Is it also an entire function? Please let me know. Okay. Please let me know. Yes. Which characteristic equation, Ananta? Acha, CR equation you're talking about. Yes. F1 to analytic. What about F2? What about the F2? So देख लेते हैं. F2z is z bar. That is z star. Okay, that is z star. चलो check कर लेते हैं ना. Now what is z star, dear? Let us check this. Complex conjugate x minus iy. Okay, so here what is the value of u? U is x only. What is the value of v? V is minus y. You compare it with u plus iv. Just have to compare with u plus iv. Okay. Now what is the ux? That is equal to 1. Uy, derivative with y will be 0. Now what is the value of vx? 0. Derivative with x is 0. What is the value of vy? Minus 1. Okay. Now देखो. As per the CR equations, okay, ux should be equal to vy. This itself fails. Second wala to match ho jayega, I think. Uy is minus vx. That is okay. Okay, 0 and minus 0 are same, but ux should be vy. Is it matching, dear? Is it matching? Then how do you say option number A? The CR equation failed. The function cannot be analytic at any cost. The CR function has failed. Okay, ux equal to vy. No, it is negative of it. It is negative of it. Okay, so it is not analytic. This has failed. Look into it. Okay. So the function f2 is not analytic. Okay, so only f1z is analytic, dear. Only the f1z is analytic. Option number B. Okay? It's option number B. Please check out, dear. Be very clear. It's option number B. Okay. Next question. Okay, let fz is equal to x square plus ay square plus ib xy is a complex analytic function of z equal to x plus iy. Then what is the value of a and b? What is the value of a and b? Okay, when such questions come, okay, some unknowns a and b are given. Okay, some unknowns a and b are given. Okay, how do you find the value of the a and b? Come on. Yes, it's basically CR because, okay, they clearly mention it is a complex analytic function, and because they mention it is an analytic function, you can go for the CR equation. Okay, you can go for the CR equation. Okay, ux should be vy, number 1. Okay, now this is your u, this becomes the v. Okay, what is ux? Differentiation with x, 2x. Okay, what is vy? Differentiation with y will be bx. Okay, so यहाँ से आ गया ना b equal to 2. Okay, that is the first CR equation. What is the second one? uy equal to minus vx. What is the uy? Okay, differentiation of u with y. So ay square का derivative 2ay equal to minus vx. What is the differentiation with x? Okay, minus by. Okay, differentiation with x, x ka derivative 1, by is the constant. But what is the value of b that is obtained is 2. Okay, so 2ay is minus 2y. Comparing a equal to minus 1. Comparing a is minus 1, so a equal to minus 1 and b equal to 2. Answer is b. Answer is the option number b. ठीक है? Cool. Answer is the option number b. Chalo. Next question then. Correct. Yeah, Ashok, Ananta, Hari, Sagnika, Bhanu, Chaitanya. Correct answer is B. Next question. What is the value of P for which the function defined in the polar form, okay, as fz is equal to r square cos 2 theta plus ir square sin p theta is analytic? Okay. The function is defined, okay, in the polar form. Okay, in the polar form. And it should be analytic. Analytic means again CR equation. What is the CR equation in the polar form? Okay, it's a function of r theta. Okay, so u of r is 1 by r v theta, del v by del theta, and second is u theta is minus r del v by del theta, that is minus r v theta. Minus r vr. Okay. Okay, del u by del r is 1 by r del v by del theta. Okay, I think these are the CR equations. Yeah, here it is. Okay, del u by del r is 1 by r del v by del theta. Short form में लिखते जा रहे हैं. UR is equal to 1 by r v theta and u theta should be minus r vr. Okay. चलो, solve this and tell me the value of P. Solve this and tell me the value of P. I'll just bring my charger. Just stay updated, guys. चलो हाँ Yes, Ananta, complex integral भी cover करेंगे. So what are you coming up with? P equal to 2. Okay, चलो. P equal to 2. So let's start checking it actually one by one. Okay, so what is the value of u and what is the value of v? U is cos 2 theta. Sorry, r square cos 2 theta. And v is equal to r square sin p theta. Okay. So what is ur? Differentiation with r square ka derivative 2r. So I have 2r cos 2 theta. And what is u theta? First let me calculate the derivatives. So cos 2 theta derivative will be minus 2 sin 2 theta. Okay, then here v. Okay, first vr. Differentiation with r, again 2r sin p theta and v theta. What is the v theta? Sin p theta derivative will be p. Okay, cos p theta. Okay, now let us put these equations here. ur, okay, ur, that is 2r cos 2 theta should be 1 by r v theta. Okay, 1 by r v theta. V theta is p r square cos p theta. ठीक है, तो यहां से क्या सॉल्व हो जाएगा? Okay, what you are getting from here is 2r cos 2 theta should be equal to r एक बार cancel होगा, pr cos p theta. So either you compare the coefficient of r or either you compare the coefficient of theta, p equal to 2. That's it. And you're getting it from one only. Okay, you're getting it from one equation only. Both the equations should be satisfied. So from one only I've got p equal to 2. You can stop here. Okay, you can stop here. Okay, you can stop here. Done it. Now, can you answer me the next question before I tell you the approach? A function, okay, fz is u plus iv. If u is x square minus y square, okay, if only the real part is given, okay, find the function fz. Find the function fz. If only the real part is given, find the function that is fz. Yes, only the real part is given. Okay, but what is the important condition given is that it is analytic function. What is the important condition mentioned is that it is analytic function. Okay, now see, when only the real part is given, okay, when only the real part is given, how do we proceed actually? Okay, so we know that the function, if I want, it is u plus iv, but only u is given to me. Okay, the u is given to me. Okay, and we need to find v. Okay, only u is given to me and we need to find the value of v. How do we find the value of v? Okay, so let us start by derivative. We know fz is u plus iv. The f dash z is dw by dz. Okay, and now let us take the derivative with respect to x, partial derivative with respect to x. So let's call it as del w by del x. So that becomes how much? Del u by del x plus I del v by del x. Okay, but dear, del v by del x are not given. Only u given, so we can find del u by del x. But v, how will you find v? यहाँ पे आप CR equations apply कर देंगे. Okay, as per the CR equations, which CR equation? Second CR equation. Okay, second CR equation. What was second CR equation? Uy equal to minus Vx. That means Vx. Vx बोले तो del v by del x. That is what I want, na? Del v by del x equal to minus on the other side minus del u by del y. ये CR equation से निकालेंगे. Okay. So minus del u by del y. Okay, so del v by del x is now replaced as minus del u by del y. Now u will be given to you and u is given. You can calculate both del u by del x and del u by del y. So you can calculate f dash z. Now what is fz? It is basically the integral of f dash z at the point z comma 0. There is a theorem. Again, we don't derive it right now, but there is a theorem known as Milne-Thomson theorem for analytic function. Okay, if you have any analytic function in terms of x and y, you can replace x by z and y by 0 if you want to represent the analytic function in terms of z. Okay, if you want to represent the analytic function in terms of z, replace x by z and y by 0. Okay, let us now understand this whole procedure. in this given example. Okay, in this given example. Chalo, dekh lete hain. So what is this given example? U is given to me. X square minus y square. Okay. I want fz. What is fz? U plus iv. So what is f dash z? As I told you, f dash z. Okay, let us calculate it as, okay, so this is w. W equal to fz. Okay, so dw by dz, and that is equal to del w by del x. I am differentiating with x, and then that is equal to, del u by del x. Differentiate both the sides with x, plus I del v by del x, and then that is equal to del u by del x minus I del u by del y. Because from CR equation, okay, you will replace del v by del x as minus del u by del y from the second CR equation, correct? Okay, from the second CR equation, so del u by del x is minus del v by del x is minus I del u by del y. Okay, so now I need both the derivatives of u, and this is achievable because u is given to me. Okay, what is del u by del x? That is known as 2x. Okay, and I want del u by del y. So dear, what is del u by del y? That is known as minus 2y. That is known as minus 2y. Let us come and substitute here, dear. So what is the value of f dash z? What is the value of the f dash z? So f dash z becomes del u by del x, which is 2x, minus I del u by del y, which is minus 2y. Minus minus plus, so this is basically 2x plus I 2y. 2x plus I 2y. Okay. You can write it as 2z also. Okay, but dekho. What is f dash z? That is known as 2x plus I2y. Okay, in this if you take 2 common, you have x plus iy, and x plus iy is automatically z. Or you can apply f dash z 2x plus I2y. If you directly not able to collect the z, what you can do? Question may given an analytic function, so you can apply the Milne-Thomson theorem. Milne-Thomson theorem says replace x by z and y by 0. So if you replace x by z, okay, it becomes 2z, and you replace y by 0. So ultimately you get 2z. That is what Milne-Thomson theorem is. Okay, you can replace x by z and y by 0. Okay, so anyways f dash z is obtained, and once you have f dash z, what is fz? It is integral of f dash z at the point z comma 0. That means after replacing x by z, y by 0. Okay, now this is going to be integral of the form 2z dz. Okay, and what is integral 2z? Z square. But because it's an indefinite integral, plus c. I'll call the answer as fz is equal to z square plus c. Fz as z square plus c. So what is the question? Real part given, you have to find the imaginary part. You have to find the complete function. Second category of question, us pe bhi aayenge. Given the real part, find only the imaginary part. Directly us pe bhi aayenge. We'll come to that also. Okay. We'll come to that also. Just wait. Okay. Chalo guys, quickly one more. If u is equal to x cube minus 3xy square plus 3x square minus 3y square plus y is the real part of analytic function. This is the real part of analytic function. U is given to you. Then find the analytic function. So quickly guys, what is f dash z? As we have discussed, okay, del u by del x plus I del u by del y. Okay, because the analytic function is u plus iv, so I am taking the derivative with x. So del u by del x plus I del u by, del u by del x plus I del v by del x. First u plus iv ko differentiate kiya with x. Okay, now I will apply the CR equation. So del u by del x minus del v by del x is minus del u by del y. Now I have applied the CR equation. Okay, now I can substitute both. So these are simple questions actually, but very important question. Okay, there are 2 important questions from analytic function. Given you, actually 3 important questions from analytic function. Number 1, okay, find the value of unknown like a, b or p. That question we were solving. Number 2, given you, find the function fz. Number 3rd question aage lenge. Given you, directly find v. I'll tell you that approach also. Okay, so what is f dash z here? Okay, del u by del x. Differentiate with x. Okay, so 3x square. Partial derivative with x hai. Okay, so minus 3y square plus 6x. That's it. Minus I del u by del y. Differentiate with y. Okay, y square ka derivative 2y. So this becomes minus 6xy. Okay, then this is minus 6y. That's it. But we need to find the value at z comma 0. So dear, what is the value of f dash z at the point z comma 0? Means put x equal to z. Okay, put the x equal to z. ये भी 6x था, correct? Yeah. So I've put x equal to z, but y will be 0. Okay, and if y is 0, the entire imaginary part is 0 here. So 3z square plus 6z. Now what is the value of fz? Okay, it is integral of f dash z at the point z comma 0. Okay, so 3z square का derivative z cube by 3. Okay, so 3 cancel, plus 6 z का derivative, z का integral z square by 2. So my answer is z cube, sorry, plus the constant of integral also. So my answer would be z cube plus 3z square plus c. Z cube plus 3z square plus c या plus 1 plus c. I think option number C we can match here. Okay, ये minus तो नहीं था ना by chance. That was plus 6z. Yeah, that is perfect, plus 6z. Differentiation with y, both are continuing. ठीक है, perfect है. With x, let me also check. Yeah, correct है. So we can see whether the constant is, c or 1 plus ic, that can be manipulated. Now my correct answer is matching up with the option number C. My correct answer is matching up with the option number C. ठीक है, with the option number C. Chalo, now next. Okay, now we know that fz is u plus iv. Okay, and if that is an analytic function, okay, then u and v are both harmonic functions. Achha, by the way, both are harmonic functions. A quick review. Okay, from the two variable function. See, for what is harmonic functions? Okay, if a function satisfies the Laplace equation, okay, a real valued function, okay, a real valued function phi, okay, that has continuous second order partial derivatives and satisfies the Laplace equation. Satisfies the Laplace equation. What is the Laplace equation we know? Okay, del 2 phi by del x square plus del 2 phi by del y square equal to 0. So any function, any real function which satisfies del 2 phi by del x square plus del 2 phi by del y square equal to 0, okay, is said to be a harmonic function. Okay. So what is this theory telling you? That if fz is an analytic function, then both the real and imaginary parts will be harmonic function. Okay, that means del 2u by del x square plus del 2u by del y square equal to 0, and also del 2v by del x square plus del 2v by del y square equal to 0. Okay, equal to 0. Acha, why? Why? Okay, see, I'm telling you, we don't need the derivation here, but this is very simple, coming up from Cauchy-Riemann equation only. This is nothing new. Okay, Cauchy-Riemann equation. Differentiate the first Cauchy-Riemann equation with x, differentiate the second with respect to y. You will get the answer. Okay, you will get the answer. Okay. Okay. Chalo. Okay. So that is what it is. So whenever fz is an analytic function, both u and v individually, they will be harmonic functions, and they are also said to be conjugate harmonic function of each other. They are also said to be conjugate harmonic function of each other. Conjugate harmonic function of each other. तो यहाँ से देखो कैसा क्वेश्चन आ सकता है. Suppose you are given the function u. Okay, consider the function u, 2x plus y cube minus 3x square y. Determine its conjugate harmonic function. What does it mean? Okay, what is a conjugate harmonic function to u? That means determine v. Conjugate harmonic function means determine v. Okay, or there can be a straightforward question. The real part of analytic function is given to you. Determine the imaginary part. Both of them mean the same question. केवल language आप देख लीजिए. Both of them mean the same question. Okay, given you, find v. Okay, they can ask either in the terms of conjugate harmonic function, or they can directly find the imaginary part if u is the real part of function. So इससे पहले क्या question देख रहे थे? If u is the real part of a function, find the analytic function fz. Now I don't want fz, I only want the imaginary part v. Okay, I want the imaginary part v. Now देखो, there is one approach. What is the one approach? Okay, find the fz. Okay, find the fz like previous question में किया. Okay, I got the fz. Now in the fz again I will put z equal to x plus iy. I will again put z equal to x plus iy, or I will open z cube, z square and etc. Okay, and then find what is the imaginary part coming up overall. But that will be a little bit more lengthy. So don't find fz, don't follow this approach. But what you can do is, okay, find the imaginary part v. How to find v? How to find v? How to find v? Dekho. Let us start with dv. Okay, let us start with dv. How can you find dv? dv can be obtained as del v by del x into dx plus del v by del y into dy. अब ये del v by del x और del v by del y कैसे आएगा ये तो पता ही नहीं है. I'll tell you that also. Okay, but dv okay can be obtained as del v by del x into dx plus del v by del y into dy. Right? Okay. Yes, that is a total differentiation concept basically. That is basically the total differentiation concept. Okay. ठीक है. But अब CR equation आएगा. Okay, as per the CR equation, what is del V by del X? Del U by, यहाँ पे आएगा second CR equation. Okay, because del U by del Y is minus del V by del X. And यहाँ पे आ जाएगा first CR equation. Okay, del U by del X, Ux is equal to del V by del Y. Okay, so using this, I can say that what is the value of dv? Okay, now what is del u by del y? What is del v by del x? Minus del u by del y. Minus del u by del y. Plus, okay, what is del v by del y? That is del u by del x. That is del u by del x into dx. ठीक है. What is the u given to me? एक बार rewrite करेंगे u को 2x plus y cube minus 3x square y. Okay, so what is the value of del u by del y? Straightforward यहीं put करते हैं. Del u by del y differentiation with y. Okay, 3y square. Okay, minus 3x square. Okay, dx. Okay, that is dv. Okay, that is dv. Okay, then what is del u by del x? Del u by del x, del u by del x. Yeah, that is 2. Okay, minus 6xy dy. Okay, 2 minus 6xy dy. Okay, now you can rearrange the terms and try to get the answer. Come on, can you do this one quickly, dear? Just rearrange the terms and see how can you. This is dv. I don't want dv. I want you to calculate v. Okay, by some basic rearrangements or basic integration, whatever you want to perform, I think you can do it now. So Ananta says one answer. Guys, come on, complete this and let me know the answer then. Please complete and let me know the answer then. X cube plus 2y minus 3x. So there is one more approach. Agar if required, I'll talk about that also. Okay, just a second. Yes, Musab, correct. चलो, yeah, so that is what I was waiting for. अच्छा, by chance differential equation पे भी study करना है तो you know I have already taken one video earlier, complete differential equation in one shot. Okay, so that also you can refer to. Okay, so what is dv? Yeah, let's come here. What is dv? Let me rewrite here so that I start solving. Okay, let me take the minus inside basically. So that becomes 3x square minus 3y square dx plus 2 minus 6xy dy, and you can compare it with mdx plus ndy basically. You can call it as mdx plus ndy. Okay, now dear, what is del m by del y? What is del m by del y? This is my m. So differentiate with y, I get minus 6y. And what is del n by del x? What is del n by del x? Differentiate this with x. Okay, so again 2 तो constant है, x का derivative 1, I get 6y here. Oh sorry, this is also not y square, del m by del y था, this is also minus 6y, y square का derivative 2y. Both of them are equal. Both of them are equal. So you get that del m by del y is equal to del n by del x. And dear, whenever del m by del y is del n by del x, such a differential equation is said to be exact differential equation. It is said to be exact differential equation. It is said to be exact differential equation. Okay. And then what is the solution of exact differential equation? What is the solution of exact differential equation? It is given by the formula integral m dx. Okay, by treating y constant. See, when you're doing the m dx, y should be constant. Okay, plus integral of terms of n not containing x. Not at all containing x. Terms of n not containing x dy equal to constant. Okay, this will be the solution. Integral m dx plus terms of n not containing x dy. Okay, correct? Yes, correct. So if you do it this way now, if you do it this way, let's integrate both the sides. So dv integral will be v. Okay, dv integral will be v. Integral m dx. What is m? 3x square minus 3y square dx. When you integrate m, y should be constant. Plus integral of, listen to me, terms of n not containing x. Terms of n not containing x. So ये वाला term आना ही नहीं चाहिए. So what is the only term you will take? That is 2. That will be equal to 2. So that is 2 dy. Okay, that is equal to 2 dy. Okay. So what is the v? Eventually solving up, what is the value of v? Oh. What is the value of v? Integrating here. Okay, y constant है, 3x square का derivative will be x cube. With respect to x I am differentiating. Y constant है, तो 3y square constant. Dx integral is x plus 2 dy. Okay, dy integral y and plus overall one constant of integral. Okay, so answer is x cube minus 3y square x plus 2y plus c. X cube minus 3y square x plus 2y plus c. That is the answer for v. That is the answer for v. Okay, you can solve it from the total differentiation approach. Okay, dear. Any doubts you can let me know here. Okay, the total differentiation approach to be used basically. ठीक है जी. Okay, and if this is clear, see a straight gate 2 mark question. Okay, on the similar concept is a homework for you. Okay, given because very similar question, then find the conjugate harmonic function v. Find the conjugate harmonic function v. Given you, find the conjugate harmonic function that is known as v. Find the conjugate harmonic function that is known as v. Okay, so I hope you will do it as homework. Okay. ठीक है जी. चलो, now moving ahead to the next question. Yeah, so before we take up that, important updates for you that yes guys, 7th January, that is Sunday. Okay, starting from 9 a.m. up to 9 p.m. at any time on your convenience, you can now appear in the BYJU'S National Scholarship Test. Yes, appear in the National Scholarship Test, and this gives you a chance to win up to 90% scholarships on the GATE preparation programs. Okay, so perform well, get your scholarships, and take a next step towards the success. Okay, in the GATE or engineering services examination. Both the modules are available. And yes, guys, okay, 3rd of January, that is today, on the BYJU'S exam prep app. Today evening 7:30 p.m. on the BYJU'S exam prep app, all your favorite Richa ma'am is bringing you a very important workshop. Okay, the tips to handle stress. Okay, during the GATE preparation. Yes, there are a lot of instances come in our preparation where we start feeling stress. How to avoid them? How to handle it? Okay, Richa ma'am is going to explain you wonderfully. So join live today on the BYJU'S exam prep app. If you don't have the app, just go to the description of this video. You will find the link. Click on the link. You can download the app. Okay, you can download the app. ठीक है जी, चलो. Next, evaluate. Now coming to integral. Okay, we'll set the rhythm for integral. First, taking a very simple integral. Evaluate integral 0 से 3 plus I 2z dz along y equal to x by 3. Along the line y equal to x by 3. Now what is y equal to x by 3? Y equal to x by 3 is basically a straight line. Y equal to x by 3 is basically a straight line. Okay. Now, how do you integrate along a straight line? Very much similar rules like you use in the vector calculus also. Line integral. Okay, line integral. So I'll tell you two things here. I'll tell you two things here. Okay, I have integral. Okay, 0 say 3 plus I. Okay, 2z dz. Okay, now what is z? Z is equal to x plus iy. Okay, so what will be dz? That will be dx plus I dy. That will be dx plus I dy. Okay, but you are not integrating anywhere. You are integrating only along a straight line. Okay, you are integrating only along a straight line whose equation is given to you. Okay, so use the equation y equal to x by 3. If y is x by 3, dy will be dx by 3. Okay, so how does the integral now look like? You have the integral 2z. Okay, what will be z? X plus iy into dz dx plus I dy. Okay, now put down the values. 2 is the constant, bahar likh liya. X plus iy, what is the value of y? X by 3 into dx plus I dy. Dy is also dx by 3. Now pay attention. What is this equal to? Okay, what is this equal to? This is further equal to 2. Now देखो x common लिया तो 1 plus 1 by 3. Okay, 1 plus 1 by 3 will be 4 by 3. Constant outside. Even if you take dx common, तो 1 plus that will be I by 3. हाँ. Sorry, ये भी I by 3 था ना? Sorry, I missed that I think. Okay, so 1 plus I by 3. It's not 4 by 3. I'm sorry. 1 plus I by 3. Clear? I can take outside. 1 plus I by 3 from both the places I'll take outside. Ultimately, it's complex, but it is constant. Okay. Then you are left with what? Then you are left with integral of, okay, यहाँ बचा x, यहाँ बचा dx. Then you are left with integral x dx. Now, since you are left with only integral x with dx, I will put the limit of x only, na? I will only put the limit of x. So, what is the limit of x then? Okay. Now, z is 0 से 3 plus iy. So, this is 0 means x and y both 0. And here, 3 plus iy. What is the real part? 3. Okay, so x is 0 up to the 3. Put the limit of only x, na? Put the limit of only x. So your answer is 2. Okay, 1 plus I by 3 ka whole square into x ka integral x square by 2. Limit 0 se 3. So देखो 2 से 2 cancel किया. Now open up. Okay, a square, b square, I square is minus 1. So minus 1 by 3 plus 2ab. So that is 2i by 3. Okay, into ये 2 से 2 cancel हो गया था. 3 square will be 9. Okay. So what I am getting is 2 by 3 plus, okay, 2 by 3 तो common ले लिया into 1 plus I into 9. So 9 into 2 by 3, that will give you 6. So my answer is like 6 into 1 plus I. Now my answer is like 6 into 1 plus I. ठीक है? I have integrated along this line. I have integrated along this line. Just a second here. Class. हाँ, ऑफिस में, क्लास में. Okay, yeah, sorry. ठीक है, now look into it. 2z dz. Okay, what is 2z dz? I have integral 2z dz. Look into this, and that becomes, if I directly integrate in terms of z, okay, that is 2z ka integral z square by 2 if I use the regular formula like we use in the real world. So that is z square. Okay, and now I will put the limit of z, that is 0 say 3 plus I. Okay, so this looks like 3 plus I whole square minus 0, lower limit is 0. Okay, 3 square 9, I square minus 1. Okay, plus 6i. Okay, plus 2ab. So this is 8 plus 6i. That is 8 plus 6i. और यहाँ पे कितना आया है? 6 into 1 plus I है ना? Difference ही है ना? Correct. A square plus b square, that is 2z. हाँ. The line is okay. The problem is the point y. हाँ नहीं, correct है, totally correct है. There isn't any doubt. Let me just check. I just need to check one thing here to be confirmed. Z is x plus I by dx plus I dy. Y is equal to x by 3. Dy is dx by 3. So then what I did next was, okay, x common and dx common. So 1 plus I by 3 outside, 1 plus I by 3 ka whole square. Let me be just sure. Okay, and then this is x ka integral x square by 2. Perfect. And that is 9. A square plus b square. I have done some calculation error here. Okay, guys, you can also correct me with the calculation, guys. Are you all alert? Okay, I by 3 ka square, that is 1 by 9 plus 2I by 3, and then this is equivalent to, guys, you can also correct, na? Okay, 1 minus 1 by 9, 8 by 9, okay, plus 2I by 3 whole multiplied by 9, and now this is equal to 8, 9 cancel, plus this is 6I. That's why I wondered how the answer is coming as different. Okay, 8 plus 6I. Okay, let us say this is your method number 1 and let us say this is your method number 2. We get the same answer directly by integrating with z. Okay, you can directly integrate with z as well without using the path. It is going to be independent of path if you have an analytic function. Okay, method 2, okay, if fz is analytic. Okay, if fz is analytic. So what is the function you are integrating, dear? What is the function you are integrating? 2z, and 2z is what? It's a polynomial category. Okay, it's a polynomial category. It's a polynomial category, and hence it is always analytic. Okay, polynomials, sinusoids, exponentials, they are always analytic. That is what we have already concluded earlier. Okay, so if the function fz is analytic, then you know its integration is going to be independent of path. Like you learn the line integral, like you learn in the line integral vector calculus. Okay, the line integral is path independent. There we learn with respect to curl concept and all. But here, if the given function fz is analytic, then its integration is going to be independent of path. Then we need not use the equation of path. We can directly integrate with respect to z. Directly integrate with respect to z. Okay? Directly integrate with respect to z. That is what it is. Answer either ways. Either you solve by this method 8 plus 6i or the first method 8 plus 6i. Okay. Now, let us come to the next. Evaluate z minus z square dz where c is the upper half of the circle mod z equal to 1. C is the upper half of the circle mod z equal to 1. C is the upper half of the circle mod z equal to 1. Now here also, if you want, you can start with z equal to x plus iy and dz is equal to something like dx plus I dy. But here it is a circle equation, mod z equal to 1. Okay. Whenever you have the circular form, you can go to the polar coordinates also or Euler coordinates. What is the Euler form of complex number? Okay. Okay, you can use z is equal to r e power I theta, but r is equal to 1 here. ये है ना mod z equal to r is equal to 1 here. Okay, so here z is equal to e power I theta. Z is equal to e power I theta. But it is not the complete circle. It is only the upper half of the circle. It is only known as what? It is only known as the upper half of the circle. What is upper half of a circle? Semicircle basically. Upper half of a circle is basically the semicircle. Okay, upper half of the circle. Mod z equal to 1. Okay, mod z equal to 1, circle of radius 1. But I don't want the entire circle. I only want the upper half of the circle. I only want the... what is happening? I only want the upper half of the circle. I only want the upper half of the circle, this one. Okay. Now, since this is the upper half of the circle, z is equal to how much? E power I theta. But what is theta here? 0. And what will be theta here? At the extreme point? What is the theta on the negative x-axis? When you measure the angle from positive x-axis and come up to this point, you get 180-degree angle. E power I pi, and e power I pi will be -1. Okay, the z is equal to 1 to -1. Okay. And by default, if no direction is mentioned, we take the direction of any contour as counterclockwise, anti-clockwise. Ab dekhiye, is this analytic function? This is again polynomial function. This is again polynomial function. This is again polynomial function. So dekho, okay, what is the integral of z? What is the integral of z? Z square by 2. What is the integral of z square? Z cube by 3. Okay. Z का value ठीक है. So from z is equal to 1 up to -1. From z equal to 1 to -1. Z equal to 0, 1. This is z. As a point 1, 0 you can write, but this is z value directly I'm writing. Chinmay and Ashek. Anything else you want to mention here? Okay, now if I put down the limits, chalo, let me put down the limit. Okay, what is going to happen? Okay, -1 square and +1 square, they will be the same. Okay, okay, so what is -1 का square? 1 -1 का square 1 होगा, तो ये 1/2 minus -1 का cube is -1 का cube is -1, तो ये हो गया -1/3. Okay, lower limit में आ जाएंगे, तो that is 1/2 and then 1/3. So eventually guys, 1/2 cancelled. This is +1/3. And again minus plus 1/3, so you have total 2/3 is the answer. 2/3 is the answer. Again, yeah, I have solved directly in terms of z. Why I have solved directly in terms of z? Why I have solved directly in terms of z? This is analytic function. The given function fz is analytic, so we can solve directly in terms of z. Okay, need not use the path. Where did I use the path? What is that I have used? I have used z equal to 1, z equal to -1. I have used the initial point and final point. Okay, but where is the path? I have not used the path here. I have not used the equation of the circle here. Not at all used. Now, only initial and final limit is used. But what is the equation of the circle? That is nowhere used in this. Okay, because whenever you are integrating the analytic function, it is going to be independent of path. Okay. So there is some concept, some type of concept that is related with the vector calculus here. But now let us come to the very, very important part. Okay, these questions are also not that important. Let us come to the very, very important part. इससे पहले क्या देखा? इससे पहले हमने एक line देखा, along a straight line. Okay, along a straight line. Okay, now I have seen a semicircle. Both of them are open paths. Okay, both of them are open paths. Okay, yeah, Ashok, if it is not analytic, then you will put down the value of z. Okay, like the method number 1, na? Okay, z equal to x plus iy. If it is circle, okay, then don't prefer Cartesian form. ये भी रख सकते हो, but Cartesian will be lengthy. But if it is circular symmetry, okay, then put the polar form or Euler form, r e power I theta. Then you have to solve by putting z equal to r e power I theta, dz is equal to r e power I theta, I d theta. ठीक है, तो तब वैसे ही करोगे. Now I have next question for you. Evaluate integral z square dz where c is the complete circle. यहाँ पे circle बोला है. Circle का मतलब है complete circle. Okay. Now when I talk about complete circle, now coming to the very, very important ideas. Now when we talk about complete circle, okay, this forms a closed path. Now this forms a closed path. Okay. Okay. Yes, Musab, correct. This forms a closed path. No, I even did not go along x-axis. मैंने बताया ही नहीं मैं कैसे गया मुझसे. I only used 1 and -1. I have only used 2 points of x-axis. I also did not say I am going along the x-axis. Okay, I have only used these 2 points basically. Idea ये है, I have used these 2 points. Maybe I have gone like this. Who told you? I did not tell you. That is my secret, है ना? That is my secret. Okay, you can assume anything. Maybe I have gone like this. Maybe I have gone along x-axis, but मैंने कुछ बताया ही नहीं है. Okay, that means I could have gone along any path. I have only used point A and point B, nothing else. That is what independent of path here means. ठीक है? चलिए, let's come here. Let us continue this. It is a closed path. So dear, ultimately fz is an analytic function. Okay, and because it is an analytic function, okay, I can integral z square directly, that is z cube by 3 from some initial point to the final point. But dear, because I am integrating along a closed path, okay, what does it mean? Okay, initial and final same होगा ना. Bhai, what is closed path? You start and end on the same point. You start and end on the same point. Suppose I start here and I end here. Any beginning you can take, but you have to travel the complete closed path. Now, because initial and final limit dear same hai, okay, so when you put the limit, okay, suppose the initial and final both are equal to suppose x, so x cube minus x cube answer kitna aayega? Tell me the answer actually. Tell me the answer actually. The answer actually is 0. The answer actually is 0. Correct hai na? Dear, whenever you do the integration of any analytic function, okay, इससे पहले भी analytic function का किया था. Okay, when you do the integral fz dz for any analytic function, but over a closed path. In the previous two questions, there was a straight line or a semicircle open path. Whenever you integrate an analytic function over any closed path, not necessarily circle, okay, the result would always be 0. The result would always be 0. That is the first thing you study in the form of, okay, पहले इसको देखते हैं, बाद में उस स्लाइड पे जाएंगे, in the form of Cauchy's theorem. Cauchy's theorem. If fz be analytic function, okay, if fz be analytic function at each point within and on a closed curve C, at each point within and on a closed curve C, then integral fz dz equal to 0. Okay, it may be not analytic outside. भाई यहाँ पे तो कौन सा फंक्शन था? यहाँ पे तो पॉलिनोमियल फंक्शन है z square. It is analytic everywhere. But what I only want that the function should be analytic at each point within and on the curve. At least with respect to the curve, it should be analytic. It may be not analytic outside the curve. That doesn't matter to me. Let me explain you this point. Okay, let me explain you this point here. Okay, suppose I take a question here. I take a question here. Suppose the question is integral e raised to the power z upon z minus 3 dz. Okay, over mod z equal to 2. Over mod z equal to 2. Listen to me now. What is mod z equal to 2, dear? Okay, what is this mod z equal to 2? Mod z equal to 2 is undoubtedly a circle of radius 2. You have a circle of radius 2, isn't it? You have a circle of the radius that is equal to 2. Okay. Now function is e power z upon z minus 3. Okay, what about z equal to 3? Z equal to 3 is basically a pole. Okay, z equal to 3 is basically a pole because when you put z equal to 3, okay, you get 1 upon 0 form, and 1 upon 0 is infinity undefined. What is pole basically? What is pole? We all know the value of z for which the function is undefined. The value of z for which the function is undefined, that is the pole of the function. Okay, but if the function is undefined, it will not be differentiable also. If a function is undefined, it will also be not differentiable at that point. Okay, so at z equal to 3, the function is not analytic also, and hence it is a singular point. Z equal to 3 is a pole, and it is also singular point. Every pole will also be a singular point. हमने define किया था ना what is a singular point. Okay, the point at which function is not analytic. Acha, how do I mark the pole? I mark the pole, okay, by this cross symbols, and the pole is z equal to 3. But the radius of the circle is equal to 2. Okay, and the pole is outside. Okay, so I definitely have one point where the function is not analytic. Okay, and that is z equal to 3. But think with respect to the given curve. Okay. Think with respect to the given curve. At each point on the curve and within the curve. Curve के ऊपर और curve के अंदर. You have to worry about on the curve and within the curve. Okay. If the function is analytic at each point within and on the curve. Okay. I can say that this function is not analytic where? सबसे पहले ये लिखते हैं. Not analytic at z equal to 3. ठीक है. But analytic everywhere. Analytic everywhere. Within and on the curve. On the curve C. Suppose this is the curve C. Analytic everywhere within and on the curve C. ठीक है. Then, okay, the integral fz dz over that curve is 0. That is what is the Cauchy's theorem basically. That is what is the Cauchy's curve. आएंगे अनंता उस पे भी आएंगे, don't worry. That is what is the Cauchy's curve. Okay, integral of analytic function over a closed path is 0 if the function is analytic within the complete closed path. Okay, okay. So here the answer is 0. Okay, but if I change the circle now, let us keep the same function. Let us keep the same function, and now let me modify the question. Okay, now let me modify the question. If my question is integral e power z upon z minus 3 dz, same function, but when you integrate over mod z equal to 4. ठीक है Ananta, coming to that now. When you integrate along mod z equal to 4. Okay, now what's going to be the answer? Okay, now only difference is I have enlarged the radius of the circle. I have enlarged the radius of the circle. Okay, and so that my singular point, same function as z equal to 3, now it is inside. Okay, so now I can place a remarks here is that function is not analytic, okay, within the given curve C. Again, this is the given curve C, and function is not analytic at one point. Even at one point, not analytic, na? Because condition kya tha? It should be analytic everywhere within the given curve. Everywhere within the given curve. Okay, it is not analytic. Okay. So, integral e power z upon z minus 3 dz, okay, over the given curve C is how much? We can say that the answer is 0 if the function is analytic, but here it is not analytic. Now there are two methods to deal with this. Cauchy integral formula, and next is Cauchy residue theorem. I will focus more on Cauchy residue theorem. Simple reason is, both are simple methods eventually, but Cauchy residue theorem involves the calculation of residue. Why I will focus more there? Because independent of the integral question, many a times you directly get the question on residue calculation. You get the question on residue calculation. Directly, just calculate the residue. And here, that is why residues are very important. And if you know how to calculate residue, that means integration is just one line answer maybe. It is just one line answer maybe. ठीक है जी? Okay. Okay. So, if fz be an analytic function at each point within and on a curve C and z equal to a is a point inside C. Now see, I am not integrating fz dz. I have fz upon z minus a, where fz is some numerator part, and I want to say that that numerator should be analytic. Okay, then fz upon z minus a. There is a singular point z equal to a. There is a singular point z equal to a. Okay, z equal to a is a singular point, and that is inside C. Okay, that is inside C. Okay, like the previous problem. There is a singular point which is inside the curve. Then integral fz upon z minus a is given by 2 pi I fa. Then it is given by 2 pi I fa. Then it is given by 2 pi I fa. Okay, then it is given by 2 pi I fa. Okay, so then this is integral fz upon z minus a dz over the curve C. Okay, and that is given by 2 pi I fa. 2 pi I fa. What is the fz function? Fz means numerator. That is e power z. Okay, at what value of z? At the z equal to 3. That is 2 pi I e cube. That is known as the 2 pi I e cube. Correct? Hai? That is 2 pi I e cube. Just a second. Yeah, sorry, हाँ. ठीक है. So then 2 pi I fa. Okay, that is what is the Cauchy integral formula. Then it is the Cauchy integral formula. Next, integral e power z upon z minus 1 dz. Integral e power z upon z minus 1 dz. Okay, over mod z equal to 2. Over mod z equal to 2. Even if it lies on the curve, okay, see, Prakhar, if it lies within on the curve, if it is lying within and on the curve, then Cauchy integral formula. Then Cauchy integral formula. Okay. If it is outside, then the answer is 0. Then the direct Cauchy theorem. If it is outside, then the answer is 0. Clear, everybody? Okay. Yeah, now tell me the next one. It is a similar one only. Okay, dekho. What is the singular point? Z equal to 1. Okay, and that is inside or outside. Every time you know it need not draw, yaar. Every time you need not draw. Okay, circle mod Z equal to 2. Get the idea. Radius is 2, so 1 is inside. Okay, it is inside mod Z equal to 2 because radius is 2, na? Okay. And if it is inside, then the integral answer, okay, that is integral e power z upon z minus 1 dz will be equal to 2 pi I fa. What is fa? E power z. You will calculate at z equal to 1. जैसे यहाँ पे किया था. Okay, same thing. 2 pi I fz. Okay, fz is e power z. Put the z equal to 1. So this time your answer is 2 pi I e power 1. 2 pi I e power 1. Now tell me the next answer, dear, quickly. Tell me the next answer, dear, quickly. Tell me the next answer. Integral 2z square minus 5z plus 6 upon z minus 2. Dekho, number one point. The singular point is z equal to 2. Okay. Now, whether it is inside, no need to draw, guys. What is a circle? If it is not a circle based question, then I'll tell you the approach. Abhi to circle hai na, mod z equal to r. Radius is 5 by 2. Okay. It is inside. Okay. Mod z equal to 5 by 2. Okay, 5 by 2 is 2.5. Now 2 is less than 5 by 2. That is why it is inside. That is why it is inside. Clear? And because it is inside, okay, then what is the value of the integral? That is the integral. Acha, the function fz is analytic. Numerator should be analytic. Is it analytic? Yes, dear. It is a polynomial function, so it is analytic 100%. Okay, the answer is equal to, let us write down the answer directly. 2 pi I fz. Okay, what is fz? 2z square minus 5z plus 6. 2 pi I fz at z equal to 2. At z equal to the singular point. Put the value of the singular point in the numerator. So this becomes 2 pi I into 2 into z square. That is 2 into 4 minus 5 into z plus 6. So ये हो गया 2 pi I 8 minus 10 plus 6. Okay, the total answer ये हो गया 4 2 is 8 pi I. ठीक है जी, 8 pi I. Correct answer Ashok, correct Hari. Okay, the answer is 8 pi I. Okay, तो ये हो गया. These are still simple cases, but there are some miscellaneous cases. वो भी मैं explain करूँगा. Don't worry. I'll explain you the miscellaneous cases also. Okay. Now, one more thing I will add on here. Okay, one more thing I will add on here. Suppose in general, okay, you may have the equation of the form integral fz upon z minus a power m dz. Okay, suppose the pole, okay, is a multiple order pole. There is a pole of order m, z minus a power m, fz upon z minus a power m dz. That will be given by 2 pi I, numerator f, तो f m minus 1a, okay, divided by factorial m minus 1. ये रेसिड्यू से भी समझ लेंगे अभी. Okay, in general, if it is z minus a power m, then the Cauchy integral formula is 2 pi I fm minus 1a, where what is fm minus 1? What is fm minus 1? It is not the power, it is the m minus 1th derivative. It is the m minus 1th derivative of the function divided by factorial m minus 1. Divided by the factorial m minus 1. This is the basic Cauchy integral form, and this is for repeated pole case. Okay, multiple pole, the pole of order m. Okay. shifted circle भी दे सकता है, and we will take the question of shifted circle also. We will take the question of non-circle also. Any all varieties we will take. Don't worry. Okay. Chalo. So yeah, these are some basic problems. Now, what is residue? Okay, if fz, okay, if fz has a pole at the point z equal to a, and that is of order m, then the residue is given by 1 upon factorial m minus 1 limit z tending to a. Okay, dm minus 1 upon dz m minus 1 means m minus 1th derivative. Okay, z minus a power m fz, z minus a power m fz. Okay, limit, okay, 1 upon factorial m minus 1. अभी इसको simplify करेंगे. This is the most general formula, but I'll simplify this. Okay, limit z tending to a. Okay, m minus 1th derivative of z minus a power m dz. Okay, this is the general formula for residue. Okay, this is the general formula for residue. Okay, now let us split it into two parts. Understand this simply. Okay, suppose fz is equal to nz upon z minus a. N means some numerator function, any numerator function. Okay, suppose fz is equal to nz upon z minus a. Okay, now z minus a ka matlab only z minus a power 1. Okay, power 1 means it is a pole of first order, pole of order 1. It is repeated only one times. It is coming only one time, and such a pole we call as a simple pole. Such a pole we call as a simple pole. Okay, ठीक है. So if suppose z equal to a is a simple pole, then residue turns out to be very simple formula. Limit z tending to a z minus a fz. Limit z tending to a z minus a fz. Okay. But if it is a pole of order m, okay, and writing the fz as, here, just putting the fz as nz upon z minus a power m. Fz is nz upon z minus a power m. Okay, by the previous formula only, but I'm making it simple by this flow chart. Okay, the residue will be nm minus 1a upon factorial m minus 1. N means numerator function. Okay, m minus 1th derivative. M minus 1th derivative at the point a upon factorial m minus 1. By this only, the general Cauchy integral formula only I have copied there. Okay, but I'll tell you, focus more on residue. Okay, because residue ka direct question bhi aata hai, to focus more on these formula rather than Cauchy integral formula. Okay, just for practice we have done 2-3 problems of Cauchy integral, but our major focus will be here. Okay, the residue limit z tending to a z minus a fz. Okay, for the simple pole. Okay, for a pole of order m. Okay, for a pole of order m, okay, residue is equal to nm minus 1a upon factorial m minus 1. How do you actually define pole of order m? इसकी बात थोड़ी और detail में करेंगे later on. Okay, if required, we'll take it later on in detail. Okay, but right now focus on the residue. Okay, now, okay, then what is the integral formula? The integral, okay, of fz dz, integral of the function is given by 2 pi I into summation of all the residues which are inside the closed curve. I told you, na, if a singular point or if a pole is outside the curve, then the integral due to it is 0. Only if it is inside on the curve, then you calculate the residue, multiply by 2 pi I. Okay, then you get your answer. Okay, so tell me this answer quickly. Now you can say by the Cauchy integral formula also, or by the residue method as well. Sure, we'll take up important discussions on Bark also, Ashok. Direction will play a role. I told you, na, by default the direction is counterclockwise. Okay, by default the direction is counterclockwise. Sati, if it is clockwise, then what to do? I'll take a question. Just nothing, change the sign. I'll tell you simply. Okay, whatever you are discussing, na, we are assuming that the closed path is having the counterclockwise, anti-clockwise direction. If it is by chance clockwise direction, okay, whatever you have calculated, place the minus sign outside it. That is the only difference. Okay? Okay, chalo. So yeah, what about this? So first of all, okay, z equal to pi by 2 is a simple pole or multiple pole? Z minus pi by 2 power 1, that is a simple pole. Okay, that is a simple pole. So what is the value of residue there? Residue is given by limit z tending to a. For a simple pole kya bola? Limit z tending to a, z minus a fz. Limit z tending to a, z minus pi by 2 into the given function, that is z sin z upon z minus pi by 2. Okay, ये simple question हो गया. Z minus pi by 2, z minus pi by 2 cancel. Okay, now this is cancelled. Directly put z equal to pi by 2 then. Okay, pi by 2 sin pi by 2. Okay, sin pi by 2 is 1. So the residue is pi by 2. And if you have got the residue, then what is the integral? 2 pi I into sum of residues. There is only one residue right now. Okay, and that is pi by 2. Okay, so 2 and 2 cancel. Answer is pi square I. What is the final answer? Pi square I. Okay. Ravi Teja, depends on your branch. Okay, pi square I. Yes, correct. Ashok, correct. Aryan, correct. Ananta. Okay. Counterclockwise means positive, correct Ananta? Anti-clockwise or counterclockwise? That is the positive direction of integral. That is defined as the positive direction of integral. The answer is pi square I. Okay. The residue, now I am only asking the residue. The residue of fz is equal to z square minus sine square z upon z power 5 at z equal to 0. अच्छा, यहाँ पे z equal to 0 का order क्या है? Just wait on. Okay, just wait on for this. Okay, I'll explain you. Okay, what is the order of this? What is the order of this? For EC, there are some extra topics. You can refer to one of the video in ISRO. For electrical, it is more or less the same. For CS also, it is more or less same. You can rely on GATE syllabus. Electronics, some topics are there. So I have mentioned in one of the ISRO videos, Ravi Teja, you can go through it. Okay, dekho dear. Dekho dear. Now, what is the order of this pole? What is the order of this pole? That's going to be very important here. What is going to be the order of this pole basically? Chalo, I'll take up here. I'll take up a small discussion here before I explain you this question. Okay. Yeah, ठीक है, guys. Let me go in the flow. ठीक है. Let me go in the flow. इसका order क्या है? Z equal to 0 is a pole, but is it a fifth order pole? Is it a fifth order pole? ठीक है. There is something I need to tell you. ठीक है. थोड़ा सा wait करते हैं. इसको मैं later बताता हूँ आपको. Okay, right now let's go to this question. Let's not interrupt the regular flow. First, let's run the regular cases. Okay. Let us run the regular cases. Evaluate e power z upon z minus 1 whole square into z minus 2 upon z minus 2. Tell me. First, let us focus on the regular case. Evaluate integral e power z upon z minus 1 whole square into the z minus 2. तो देखेंगे इसको डियर. Okay, इसको देखेंगे. हाँ जी. Integral e power z upon z minus 1 whole square z minus 2. Over the three different cases. Mod z equal to half, mod z equal to 3 by 2, mod z equal to 3. अच्छा देखो डियर. Okay. What are the poles here? What are the poles here? Z equal to 1 and Z equal to 2. Z equal to 2 the simple pole hai. Because Z minus 2 power 1. But Z equal to 2. That is a pole of order 2. Right now you just look Z minus a power m. What is the confusion with that previous question? I will explain you separately. I'll explain you separately. Okay? Now, that is a pole of order 2. Okay, so, we know how to calculate the residue accordingly. We know how to calculate the residue accordingly. अब आप इसको देखोगे. Mod z equal to half. Okay, mod z equal to half. Okay, both the poles inside or outside? First of all, if the radius is half, तो pole 1 and 2 need not draw. We understand the radius is up to half, so both the poles are outside. Okay. Integral answer 0 na. Both the poles are outside. So first ka to 0 is sure. Okay. Second one. Okay. Which one? Which pole is inside? Z equal to 1 inside. Z equal to 1 inside. So what should be the integral answer? 2 pi I into residue of the Z equal to 1 pole only. Not both the residue. Only one residue will be required here. Okay. And next. Okay, mod z equal to 3. So z equal to 1 and z equal to 2. Actually both inside. Let me write like this. 1 and 2, they are both inside. They are both inside. So what is the value of the integral? That is 2 pi I, then summation of residues. Okay, so here I need both the residue. Residue of z equal to 1 plus residue of z equal to 2. Clear? Okay, everybody. So first of all, in the GATE exam, you will have any one of the three curves. I am taking three cases here. First, see which curve they are asking the integration, and the pole which is inside, only calculate the residue of that pole. Don't calculate all the residues in the beginning. Okay. Yeah, that is what Hari I am telling, na? Even in the residue. Okay, what is the Cauchy residue theorem? 2 pi I into summation of residue inside C. Okay, so that is why you have to consider inside outside, and that is what this example is here to explain you. Okay. Okay. So now let's calculate the residue basically. Okay, now Z equal to 2 se start karte hain. Let us calculate residue Z equal to 2. Okay, the residue Z equal to 2. Okay, because it's a simple pole, the residue will be given by the simple formula limit Z tending to A, Z minus A FZ. Z minus A FZ e power Z upon Z minus 1 square into Z minus 2. So Z minus 2 got cancelled. Z tending to 2. Okay, e power 2 upon 2 minus 1 whole square. 2 minus 1 is 1. Okay, so it's e square only. Oh, sorry. Correct hai. That is e square. Okay, residue of Z equal to 2 is e square. Okay, now let us come to the next. Okay, next I want to calculate the residue for Z equal to 1. Okay, but what we have observed for Z equal to 1, that is a pole of order 2. Okay, that is a pole of order 2. Okay, so my function is e power Z. यहाँ पे थोड़ा सा टेक्निक आप देखना, e power Z upon Z minus 1 whole square into Z minus 2. But dear, as per the formulas I have told you, when you are calculating, okay, when you are having Z equal to A is a pole of order M. Okay, the residue is nm minus 1 upon factorial m minus 1. But what is n? Numerator function. See, when I say numerator function, only Z minus A power m should be in the denominator. Rest everything numerator. Only Z minus A power m should be denominator. That means, okay, I have to rearrange this in the form e power Z upon Z minus 2 whole divided by Z minus 1 ka whole square. Now this is of the form nz upon Z minus A power m. nz upon Z minus A power m. Okay. Argadeep, you can solve this through Cauchy integral formula, but for that you have to first break into partial fraction. Okay. Number one, that will be a little bit more lengthy. You have to take one additional step and convert it into by using the partial fraction. Okay, partial fraction. Okay. Number two, why I focus more on residue? Because directly you get the questions based on residue. So in that case, anyways, you should know this approach. And if you know this approach, then answer is what? Substitution only. So that is why I always focus on residue, because expect question only on residue also. Many times they ask only residue question, not integral question. Okay, so वो तो पता ही होना ही चाहिए. Okay, so what is nz upon Z minus A power n? That is written in front of you. So what is the residue formula then? It is given by nm minus 1a upon factorial m minus 1. Hey, what is the value of m? It is a pole of order 2. Okay, so that becomes n1a. What is the a? A is the value of the pole. That is n1 1 divided by 1 factorial. 1 factorial 1 hota hai, so I only need the value of n1 1. n1 means the first derivative. Okay, first derivative. Now what is the first derivative? यहीं पे निकाल लेते हैं. What is nz here for the second partner? What is nz? E power Z is divided by Z minus 2. So what is the first derivative? Z minus 2 ka whole square, denominator squared. Z minus 2 constant, derivative of e power Z is e power Z minus e power Z, derivative of Z minus 2 is 1. Okay, तो ये हो गया Z minus 2 minus 1. That becomes basically Z minus 3 e power Z upon Z minus 2 whole square. So what is the value of n dash 1? Okay, put Z equal to 1. So that becomes actually 1 minus 3 into e ki power 1 divided by 1 minus 2 whole square. Put down Z equal to 1 clearly. Okay, let me just check the calculation. Yeah, perfect. Z minus 2 constant, e power Z ka derivative, Z minus 2 minus 1. Yeah, that is okay. Okay. So what is now the answer? 1 minus 3 minus 2e. Just check the calculation. Denominator is minus 1 ka square, that is 1. The minus 2e is the answer I am getting. Okay, for the second one, for the second residue. चलिए अब यहाँ पे आ जाते हैं. Let us put the answer. First, तो over. Okay, second में answer 2 pi I residue of only Z equal to 1. Residue of only Z equal to 1, that is minus 2e. That is minus 2e. Okay, so the answer is minus 4 pi EI. Correct? Eh? Okay, answer for the third one, 2 pi I. Okay, residue minus 2e for z equal to 1. For the z equal to 2, residue was calculated as e square. So we can take one e outside. So the answer is 2 pi EI into e minus 2. Just check the calculations, okay? Right. Okay, ji, done. Okay, so now we have all the three answers. We needed the residue, and whatever residue inside that only we have considered corresponding to the different curves given to me. Corresponding to the different curves given to me. Okay. Have a look into it. The value of the integral z square plus z upon z minus 1 power 10. Z square plus z upon z minus 1 ki power 10. Okay, so here what is the condition you have? Z equal to 1 is a pole of what order? Is a pole of order 10. Okay, it is a pole of order 10. So what is going to be the residue? Dear, this is the integral of the form. Okay, here the integral is of the form. Okay, numerator nikal lete hain separately. This is the nz function. What is nz? Z square plus z only. So what is the residue? Because it is a pole of order 10, the residue will be given by nm minus 1, that is n9a, that is n91, divided by factorial 9. But what is the ninth derivative of this? Dear, what is the ninth derivative of this? See, what is the first derivative? 2z plus 1. What is the second derivative? Because it's a polynomial of second degree, okay, you will be getting up to the second derivative, and from the third derivative onwards you will get 0, because constant of 2 is 0, differentiation of 2 is 0, sorry. Similarly, you have to go up to the ninth derivative, that is 0, differentiation of 0, you keep differentiating. So sometimes, okay, you can have simple manipulations. So up to the ninth derivative, when you go, it's going to be 0. Whatever value you put doesn't matter, answer is 0. Okay, chalo. Done. It's 0. Chalo. Now next example. Let's go to next example. Z square integral z square minus 4 upon z square plus 4 dz evaluated anti-clockwise around the circle mod z minus I equal to 2. Evaluated anti-clockwise around the circle mod z minus I equal to 2. Mod z minus I equal to 2. इसके around देख लेंगे. Okay, now I told you mod of z minus z not equal to r. It is still a circle, okay, but like a shifted circle. It does not have the radius equal to, it does not have the center at origin. But no problem, na? No problem. How does it matter? What are the poles? भाई poles के लिए पहले आप आ जाएंगे z square plus 4 for the poles. Let me first evaluate z square plus 4 equal to 0. Okay, so z square is minus 4 and under root of minus 4. Under root of minus 4, I am getting plus minus 2i. Under root of minus 4 plus minus 2i. Okay, plus minus 2i. Z equal to plus minus 2i. Okay, there are complex poles, no problem. But whether poles are complex or real, whether inside or outside, that is the concern. No? Okay, so can I quickly draw this? Modulus of z minus z naught equal to r, where z naught means the center and r is the radius. So what is the center here? It is I. Okay, good to know, Manju Srivastav. Okay, the center is at I. Imaginary axis 1 unit. Okay, 1 into I. Okay, and the radius is 2. And the radius is equal to the 2 units. So consider this roughly. Okay, so because the radius is 2 unit, I have a circle. This is the center, which is I. Okay, so because the radius is 2 units, I plus 2i, I plus 2, that it will be passing through 3i, and the 1 minus 2 minus 1, it is going to pass through minus I. Okay, this is the circle approximately. But what are the poles? Plus 2i and minus 2i. Now let me mark the pole. Okay, plus 2i. Definitely it is inside. Minus 2i, minus I ke niche hai. That is outside. Okay, so you have two cases. One of the pole is in, one of the pole is out. So whose residue you should calculate? Whose residue you should calculate? Only the residue, only the pole which is inside. Okay, dekho, you have z is equal to plus minus 2i. That is plus 2i and minus 2i. Okay, eventually both are appearing one time. Eventually both are appearing one time. Okay, so both are simple poles only. Both are simple poles only. Okay, both are simple poles only. So what is my function fz here? My function fz is z square minus 4 upon z square plus 4. First of all, I know the roots of the denominator. So let me write down the denominator in the factorized form. Z plus 2i, z minus 2i. Then only, when you equate the denominator to 0, then only you have plus 2i and minus 2i as the roots. Okay. Now, I want to calculate, dear. I want to calculate the residue only due to the inside pole, and inside is 2i. Z equal to 2i, which is a simple pole. So the first formula, simple formula, limit z tending to a, z minus a into the fz. So z minus 2i cancelled. Put z tending to 2i. So it's going to be 2i square minus 4 upon 2i plus 2i. What is 2i? I square is minus 1. So ये हो गया minus 4, then upon 4i. So this is minus 8 upon 4i, or minus 2 by I, or basically plus 2i. 1 upon I is minus I. Okay, this is plus 2i. Okay. Okay, so what is the value of the integral? 2 pi I into residue of inside pole. And inside, you have only one pole. The residue is 2i. Okay, multiply the answer. 2 2s are 4. You have 4 pi I square. But what is I square? Is minus 1. Answer is minus 4 pi. Good to know, Varun. Good to know. Okay, so answer is minus 4 pi. Answer is option number A. Okay, ji. So it could be shifted circle. It could be shifted circle. Now, next important case. Okay, so now we know the regular questions now. Okay, next important case, like, okay, this was shifted circle, but it is still a circle. I have drawn it. I have drawn it. Okay, I have drawn it. Now, next case देखेंगे. Okay, evaluate integral z square plus 2 upon z minus 2, where c is the closed curve. One thing is they have mentioned there is some closed curve. Okay, modulus of z plus 1 by z equal to 3. Okay, what does this curve correspond to? What does the curve correspond to? What does the curve correspond to? Acha, maybe we can find it. Okay, we need to put some effort putting z equal to x plus iy and solving it. But why to put the effort? It is a closed curve, and what you only need. This was a closed curve. Whether it is circle or any other shape, I only need that which pole is inside and which pole is outside. That is the only thing. Na? Do I need the shape of the curve? I need two things. One, it used to be closed curve, because all the Cauchy concepts are applicable for closed curve. Okay, and then I need which is inside pole and which is outside pole. I don't want the shape actually. I don't want the shape actually. ठीक है, तो closed curve है, mentioned है. But inside outside, just a second. Let us continue. ठीक है. Now what I'm telling is whether it is inside outside यही चाहिए ना. Okay, the modulus of z plus 1 by z equal to 3. Okay, देखो previous example के respect में explain करता हूँ. What was the curve? Modulus of z minus I equal to 2. ठीक है. And what are the poles? Z equal to plus minus 2i. ठीक है. Let me check z equal to 2i. Okay, and what you need to do is 2i minus I. Okay, mod of 2i minus I, how much it is? Mod of 2i minus I, how much it is? Okay, it is equal to modulus of I. What is modulus of I? 1. Okay, it is less than 2. Okay, whenever, okay, you substitute the point and you get the curve, when you get the left hand side less than the constant, then it is inside point. Okay, when you put z equal to minus 2i here, okay, यहाँ पे minus 2i put करें तो modulus of minus 2i minus I means modulus of minus 3i. What is modulus of minus 3i is known as 3. Okay, it is known as 3 and that is greater than 2. Okay, so when you get less than 2, it is an inside point. When you get greater than 2, it is outside point. Clear? Same thing you have to apply. Okay, same thing you have to apply. Don't worry, Kaushi's question will be with closed curve only, Ananta. Okay, so यहाँ पे सबसे पहले poles क्या है मेरे पास? Very simple. Denominator is already factorized form. Z equal to 1 and 2. And both are power 1. Z minus 1 power 1. Z minus 2 power 1. Both are simple. Both are simple poles. ठीक है. अब हम check करेंगे Z equal to 1. Okay. Modulus of 1 plus 1 by 1. Okay. That is modulus of 1 plus 1 is 2. Modulus of 2 is 2. That is less than 3. Okay. You're getting less than 3. Less than whatever is the right side result. At this point, okay, at all the points on the curve, mod of z plus 1 by z will be equal to 3. But if the point is inside, the magnitude less than 3. If it is outside, magnitude greater than 3. So the first one is inside. Second wala check karenge now. Okay, what is the second pole? Z equal to 2. So modulus of z plus 1 by z, 2 plus 1 by 2. Okay, that is 5 by 2. Modulus of 5 by 2, that is 2.5. This is also less than 3. This is also less than 3. So this is also inside here. This is also less than 3. So this is also inside. Okay? So both are inside. Whatever may be the shape of the curve, I don't need. Na? I only need it. It should be closed curve, which is mentioned here. And whether the poles are inside, outside, both are inside. So calculate both the residue. Okay. Calculate the residue, only the poles which are inside. Achha, here both are simple. Okay. So residue, start karte hai. Residue for z equal to 1. Okay. Limit z tending to 1, z minus 1 into fz. What is the fz? Z square plus 2 upon z minus 1, z minus 2, z minus 1 clearly cancelled. Now put z equal to 1, so 1 square plus 2 upon 1 minus 2. Okay, 1 plus 2, 3 and minus 1. This is minus 3. Now I'll calculate the next residue and that is known as the residue of z equal to 2 and that is given by limit of z tending to 2, z minus 2 into the fz. That is z square plus 2 upon z minus 1, z minus 2. Z minus 2 cancelled this time and now put z equal to 2. So 2 square plus 2 upon 2 minus 1. That becomes 4 plus 2 upon 1. 6. Answer is 6 here. The answer is 6. The answer is equal to 6. Residue at z equal to 1, residue at z equal to 2. Minus 3 and 6. Okay, so now what is the integral answer? The integral is 2 pi I into summation of residues which are inside. Both were inside. That is why both the residues are calculated. So I'll take the summation of them. Minus 3 plus 6 will be 3 and the total answer is 6 pi I. Yes dear, final answer 6 pi I. Correct Ananta, Chinmoy, Banu Prakash. Final answer is 6 pi I. Okay. Now next case. Let us keep learning different variety of cases. Okay. And meanwhile, what is the meaning of pole of Z? है ना, व्हाट इज द पोल ऑफ ऑर्डर m, वो भी मैं एक्सप्लेन करूंगा आपको, डोंट वरी. Yeah, let's come to this question. Evaluate integral 1 upon cos hyperbolic z dz where c is the curve mod z equal to 2. Where c is the curve mod z equal to 2. Yeah, correct Chaitanya, correct Ashwani. C is the curve mod z equal to 2. देखते where c is known as the curve mod z equal to 2. अब देखो यहाँ पे we have the integral of the form, यहाँ पहले fz की बात करते हैं. The fz is 1 upon cos hyperbolic function, cos hyperbolic z. Let me break the cos hyperbolic function by the Euler's formula as e power z plus e power minus z by 2. Okay, or 2 comes to the numerator. This is 2 upon e power z plus e power minus z. थोड़ा और simple करते हैं. Multiply by e power plus z throughout. So 2 e power z upon e की power 2z plus 1. Multiplied by e power z, numerator denominator. Okay. Now what are the poles corresponding to it? So as to calculate the poles, I will start taking e power 2z plus 1 equal to 0. Okay, and I have e power 2z equal to minus 1. So what is the value of 2z? Okay, what will be the value for 2z? 2z will be, to eliminate exponent, we take the log. And what is log minus 1? Log of negative numbers is not defined. Not defined in the real domain, na? But today only we learned, in the complex domain, we can even take the log of negative numbers. And that is given by what formula? Log of minus k is log of k, that is log 1 plus or minus I pi. I explained you this in the beginning of the class itself. ठीक है, log 1 तो 0 है, log 1 तो 0 है, so you have only plus minus I pi. Okay, that is 2z and z equal to plus minus I pi by 2. What are the poles we have dear? Z equal to plus or minus I pi by 2. Okay, अच्छा, plus or minus I pi by 2 means I pi by 2 minus I pi by 2, and both are simple. Both are simple poles. ठीक है, both are simple poles. ठीक है, अब देखो यहाँ पे प्रॉब्लम क्या आएगा. The problem, okay, what is the residue? The problem, residue is given by what formula? Okay, the residue for simple pole, okay, is given by the formula. कोई भी एक pole ले लेते हैं. Let us take the residue for z equal to I pi by 2. That is given by the formula limit z tending to I pi by 2, z minus I pi by 2, z minus a fz. Okay, what is the fz? 2 e raised to the power z, okay, upon e raised to the power 2z plus 1. Now denominator this time, it's not a polynomial function where you can factorize. Okay, we have got the solution through some logarithm and exponential conditions. Okay, now how to proceed forward? Can you cancel it? Okay, here basically the terms do not cancel. Here basically the terms do not cancel. You will be little bit stuck here because the terms do not cancel. So what can you do? थोड़ा सा limits apply करेंगे and then I will tell you the direct formula also. Okay, if you just apply the case of limit, okay, this is like limit z tending to I pi by 2. Take the numerator on whole. Okay, you have z, you have 2 e power z, z minus I pi by 2 upon e की power 2z plus 1, and when you put z equal to I pi by 2, this numerator will be 0 and denominator also 0 because z equal to I pi by 2, na? How z equal to I pi by 2 comes? By solving denominator equal to 0. So this is 0 by 0. And if you have 0 by 0 form, you will go to the LH rule. You have the 0 by 0 form, you can go to the L hospital. Here the terms do not cancel, so you have to go to the L hospital rule. Okay, so this is going to be limit z tending to I pi by 2, limit z tending to I pi by 2. Okay, तो numerator को differentiate करेंगे. Okay, so 2, okay, देखो 2 तो constant है, न्यूमरेटर इज प्रोडक्ट ऑफ टू फंक्शन, तो सबसे पहले e पावर z का डेरिवेटिव e पावर z, देन z माइनस आई पाई बाई टू, ओके, प्लस e पावर z कांस्टेंट एंड डिफरेंशिएशन ऑफ z माइनस आई पाई बाई टू विल बी 1 डिवाइडेड बाय डिनोमिनेटर का भी डिफरेंशिएट करेंगे तो e पावर 2z का डेरिवेटिव इज 2 e पावर 2z, दैट्स इट, प्लस 1 का डेरिवेटिव 0, ओके. नाउ ट्राई टू पुट z इक्वल टू आई पाई बाई टू, नाउ पुट z इक्वल टू आई पाई बाई टू, तो यू हैव द फर्स्ट टर्म, ओके, ये 2 तो कांस्टेंट ही था, okay, so you have 2, the first term will be 0, okay, then e power I pi by 2 divided by 2 e power 2z, तो e power I pi, 2 से 2 cancel किया, so I am getting the e power I pi by 2 upon e power I pi, तो e power minus I pi by 2, ऐसा ही है ना, e power I pi by 2 upon e power I pi, so exponents are divided, so subtract the power, basically 1 by 2 minus 1, so minus 1 by 2, e power minus I pi by 2, e power minus I pi by 2, ठीक है. अब इसको डायरेक्ट कैसे करते हैं वो भी बताएंगे, ठीक है. What is e power minus I pi by 2? e power minus I theta is cos theta minus I sin theta, minus I sin theta, तो cos theta है, cos pi by 2 0, sin pi by 2 is 1, so this is minus pi, ठीक है. अब ध्यान देना, ठीक है, डायरेक्ट रिजल्ट, the problem here was the terms do not cancel and I have applied LH rule. Every time you can apply LH rule, but from the LH rule, what is the generalized formula that I am telling you? Okay, so let the fz, okay, the given function जिसका रेसिड्यू निकालना है, let that be nz upon dz, let that be nz upon dz, okay, some numerator function, ये रहा ना fz, some numerator function upon some denominator function, okay, some numerator upon some denominator, okay, in that case dear, the residue at z equal to a is given by na divided by d dash a. Let the numerator be as it is and then differentiate the denominator. Let the numerator be as it is and then only differentiate the denominator. ठीक है. So let us use this point here. तो क्या बोला है, मेरे पास है fz. I have the fz that is equal to how much? I have the fz that is equal to, in the question we have 2 e power z upon e raised to the power 2z plus 1 and that is nz upon d dash. Okay, residue के लिए a का वैल्यू बाद में रखेंगे, use the numerator as it is and put down the derivative of the denominator. So numerator is 2 e power z upon differentiation of denominator 2 e power 2z. 2 से 2 cancel, e power z upon e power 2z will be e की power minus z. ठीक है. So now what is the residue for z equal to I pi by 2? E power minus I pi by 2, z की जगह I pi by 2. Same answer we got here, na? E power minus I pi by 2, and e power minus I pi by 2 is minus I. Residue of z equal to next pole, that is minus I pi by 2. There are two poles, na? Plus I pi by 2, minus I pi by 2. So that will be equal to e power minus z minus I pi by 2, so minus minus plus to e power plus I pi by 2, and that will turn out to be plus I cos pi by 2 plus I sin pi by 2. Okay, now what is the answer of the integral then? Both are inside क्या? अच्छा, ये भी एक बार चेक कर लेते हैं. C is the curve mod z equal to 2. ठीक है, यहाँ पे देख लेते हैं. Mod z means modulus of plus minus I pi by 2. Okay, so plus minus में mod का कोई रोल ही नहीं है. Modulus of I pi by 2 is pi by 2 and pi by 2 is approx 1.57 less than 2. Okay, less than 2 because the circle has the radius 2. That is why I'm comparing with 2. Okay, so both are less than 2, so both are inside. Because both are inside, that is why I have calculated both the residues. Both are inside. Okay, so integral then given by 2 pi I summation of the residues, but here residues are of opposite sign, minus I and plus I equal but opposite sign. Okay, so answer is 0. ठीक है dear, the answer turns out to be 0. Okay, the answer turns out to be 0. This is the next case. Next, now I shall leave you this question. The sum of the residue at the singular point z equal to plus minus I pi by 2 for the function sin z upon z cos z. You can also treat this function as tan z upon z. If you want, you can also take it as tan z upon z. Okay, tan z upon z. Okay, tan z upon z. So whatever approach you want to take, this is a homework for you. This is going to be a homework for you. Clear? This is going to be a homework for you. Yeah, I know it's 1:30, but some more cases. Let us complete. Okay, as I told you, I'll complete at least all the important areas of the complex. So that is why it is taking time. ठीक है, चलो next case देखते हैं. Now next case. Okay, the value of integral z square e power 1 by z dz. Now this is again an important case, next different variety. Here there is no numerator by denominator form. So how do you calculate the poles here? Okay, देखो, what is the function here fz? Please look into it. What is the function here? Is z square e raised to the power 1 by z. Z square e raised to the power 1 by z. Okay, अब देखना. Z square, okay, what I will do here is I will expand the e power 1 by z power series, okay, like e power x expansion. Okay, so that is given by how much? 1 plus x by 1 factorial plus x square by factorial 2, like e power x expansion. Okay, in place of x you have 1 by z, okay, plus x cube by factorial 3, etc. Okay, so expanding it, I have z square 1, then plus 1 by z, then plus 1 by 2 factorial z square, okay, plus 1 by 3 factorial z cube. Next would be 1 by 4 factorial z power 4 till infinity. Okay, till infinity. Okay, now multiply by z square. Okay, so when you open up, now I'll write it here. When you open up, what is the fz here? The fz here is, open up the bracket, so you have z square plus z, z square plus z, and यहाँ पे z square cancel, तो plus 1 by 2 factorial. Okay, plus now look into the next terms, dear. Look into the next term. 1 by 3 factorial, z square and z cube, 1 by z will still be there. Okay, so 1 by 3 factorial, okay, into z inverse. I can call it as z inverse. 1 upon z को z inverse बोल देंगे. Next term will be 1 by 4 factorial z की power minus 2. Next will be 1 upon 5 factorial z की power minus 3, and this goes on till infinity. This goes on this till infinity. Okay. Now this is the power series expansion. Okay, so I have used here the power series expansion. I have used the power series expansion here. Understand the concept here. Okay. Now, any expansion can comprise of two types of term. Okay, some terms can be in positive power of z. Some of the terms can be in the negative powers of z. Okay, some of the terms can be negative power of z. Okay, the terms with positive power of z, this much. The terms with positive power of z, including up to the z power 0. The terms with the positive power of z, including up to the z power 0. Okay, this part in the expansion is known as the analytic part. This part in the expansion is known as the analytic part. Clear? Okay. Why it is analytic part? Because simple reason is, guys, positive power of z. Positive power of z का मतलब क्या है? Positive power of z means polynomial function. So this part, if you forget every other thing, this part is a polynomial function, and polynomial functions are always analytic. So we call it as analytic part. Okay. And this part with the negative power, okay, this is known as the principal part. Okay, this is known as the principal part. This is known as the principal part. So one of them is analytic part, one of them is the principal part. One of them is analytic part, one of them is principal part. Okay, now this principal part contain how many terms? भाई ये तो चलता चला जाएगा ना. Okay, this power series expansion is up to infinity. Okay, so this contains infinite number of terms. Okay, whenever dear, okay, whenever dear principal part contains infinite terms, okay, okay, then the z equal to 0. अच्छा, actually यहां से आपको समझ में आ जाना चाहिए, okay, कि z equal to 0 is a pole. Can I say that z equal to 0 is a pole? Can I say that z equal to 0 is a pole? Okay, because चलो यहां तक तो cancel होगा, but here you have 1 upon 0 left, you have 1 upon 0 left, 1 upon 0 infinity, 1 upon 0 infinity, na? The value of z at which the function becomes undefined, that is a pole. Acha, and the pole function is not analytic also. So z equal to 0 is a pole and also a singular point. Okay, it is also a singular point. Okay, so then z equal to 0. Okay, then the singular point z equal to 0 is known as, many students are not aware about these concepts, are confused about these concepts. Then z equal to 0 is known as an essential singularity. Then z equal to 0 is known as an essential singularity. अब एक और example लेता हूं यहाँ पे मैं, ठीक है? Now there was one example, z power 5 you were telling pole of fifth order. Related to it, first let's take this example. For the function sin z upon z cube, okay, we know that z equal to 0 will be a pole. Z equal to 0 will be a pole. It is pole of which order? It is a pole of which order? Quickly tell me. Quickly tell me. It is a pole of which order? Tell me, dear. It is a pole of which order? Tell me. Tell me, यार, simple question है ये. I'm not asking residue, I'm not asking any integration. Okay, it is a pole of order 3. Chalo, some of you say 3. It is not a third order pole. Understand here, it's not the third order pole. Dear, what is the sin theta expansion? Here, let us again understand by expansion. It is not a pole of order 3. If you get this question, you get negative marks here. You'll get negative marks here. Ab dhyan dena. Okay, what is the sin z expansion? Sin theta expansion, like theta minus theta cube by factorial 3 plus theta power 5 by factorial 5 minus theta power 7 by factorial 7 and etc. till infinity. Now divide by z cube. Okay, dear. Now divide by z cube using this expansion again. Z upon z square, 1 upon z square. So z ki power minus 2. Next, z cube cancelled, minus 1 by factorial 3. Okay, next, okay, z square by factorial 5. Next, z ki power 4 by factorial 7 till infinity. But the difference here is this one, including 1 by 3 also. This one is the analytic part. What is the meaning of analytic part? I told you positive power of z will be analytic part because that comprises a polynomial function. It is always analytic. The part with the negative powers of z, that is the principal part. This one is principal part. Does it go to infinity? Does it go to infinity? The principal part does not contain infinite terms. It only contains the term up to z power minus 2. Okay, the principal part is there. Maximum up to z ki power minus 2. Maximum up to z ki power minus 2. Okay. The order of the pole is 2. The order of the pole is 2. Okay. The order of the pole is 2. Okay. The order of the pole is 2. I'll explain you some points and we'll come back to the question actually. Okay. So we know what are zeros and poles and singular points. ये तो हमने पहले define कर दिया. Okay. Pole is the value of z for which the function is undefined, but the value of z for which the function is not analytic, that is a singular point. But yeah, if the point is a pole, that is also a singular point, undoubtedly. That is also a singular point, undoubtedly. Okay. Now have a look into this example. Have a look into this example. Z plus 1 upon z, z minus 4. Okay. What are the poles here? Z equal to 0 and z equal to 4, and they are also the singular point. Okay. But if I put, suppose 4.1, I know that 4 is a pole. 4 is a singular point also. If I put 4.1, what is the value of the function? Is it still undefined? Is it still undefined? Nahi na? Okay, it is going to be 4.1 plus 1, 4.1 plus 1, that is some 5.1 divided by 4.1 into 0.1. You calculate, it is not infinity. It is not infinity. Na? The function is clearly defined. So can I say z equal to 4.1 is also a pole? No, that is not a pole. Okay. If z equal to 0 and z equal to 4 are the poles, okay, but there is no other pole around it, then that pole is an isolated pole, and that is an isolated singular point actually. Okay. So if z equal to z naught is the singularity of fz, and fz is analytic at everywhere in the neighborhood, it is not analytic only at one point, but it is analytic everywhere in the neighborhood. Okay, then the point is an isolated singular point. Then the point is an isolated singular point. Okay, some basic definition. Z equal to 0 and z equal to 4 are isolated singularity. Okay. Okay. There are no other singularities. There are no other poles around z equal to 0 and 4. Okay. Now, okay, now we can expand functions in the power series such that the expansion, okay, I'm not covering up expansions in detail today. No, if you want, if you demand, later on we can have a class on Lorentz and Taylor series. Okay, but any expansion around z equal to z naught can contain some terms which is in the positive power. It can contain some other terms which is in the negative power. Okay, the term with the positive power is analytic part. Already I explained it through example, and the term with the negative power is known as the principal part. So in the expansion, there are two parts which I have already explained you. Okay, one of them is the analytic part, one of them is the principal part. Okay. Now, if the principal part does not exist by chance, if the principal part by chance does not exist only, then such a singularity will be a removable singularity. Such a singularity will be a removable singularity. अभी इसका example भी देता हूं मैं आपको. Okay, इसका example भी देता हूं मैं आपको. Okay, now what is this? Okay, if in the Lorentz series expansion about z equal to z naught, if the principal part contains infinite number of terms, if the principal part contains infinite number of terms, okay, then the singular point is an essential singularity. Like our example z square e की power 1 by z, उस पे आ जाते हैं. Okay, I told you here, na? Here, look into it. The principal part is going to go z power minus 4, z power minus 5, z power minus 6 till infinity. So whenever principal part contains infinite term, then that singular point is an essential singularity. Clear? Okay, that is an essential singularity. Okay. Next point मैं क्या बोल रहा हूँ? Okay, pole of order m. If the principal part of the Lorentz series contains a finite number of terms, okay, the principal part, okay, contains finite number of terms up to z की power minus m. Up to z की power minus m. Okay, then the singular point z equal to z naught is a pole of order m. Okay, then the singular point z equal to z naught is a pole of order m. Okay, that is a pole of order m. तो यहाँ पे मैंने क्या बोला था? Have a look into this problem. Here the principal part contains up to z की power minus 2. Okay, and up to z power minus 2 means the pole is the pole of order 2. Okay, it is not the pole of order 3, it is the pole of order 2. The correct answer is B. The correct answer is B here. ठीक है? Correct answer is B. To understand more about this, अभी भी आपको लग रहा होगा कि denominator में तो z cube है. What is the problem? Denominator has z cube. What is the problem? देखो. To understand this even better, okay, let me write down the question. Fz is equal to sin z by z. Okay. Z equal to 0 is a pole of what order? Is a pole of which order? Tell me. Here z equal to 0 is a pole of which order? Now you may think it is a pole of first order because z की power 1 है ना. You may think that it is a pole of first order. That's what you may think, na? It is a pole of first order. Okay. So is it the pole of first order, dear? Is it the pole of first order? If you say that it is a pole of first order, it is wrong. भाई simple सा logic समझ लेते हैं. Limit z tending to 0. There are some times, okay, we feel that z equal to 0 may be a pole. Okay. यहाँ पे देखेंगे, we have limit z tending to 0 sin z upon z. As per the basic rules of limit, what it is? It is 0 by 0 form. It is 0 by 0 form. Then this is equal to limit z tending to 0, differentiation of numerator, cos z differentiation of denominator is 1. Okay, now put the value of z equal to 0. You have cos 0 by 1. Cos 0 is 1. Okay, it is a finite value. Dear, when you put z equal to 0, the function gives a finite value. So whether it is a pole or not, that is a big question. The correct answer is at z equal to 0, the function returns a finite value. Whereas what is the meaning of pole? Pole means the value of z where function is undefined. So here function is clearly defined. It gives a finite value. So what is the answer actually? Z equal to 0 is not a pole. Basically वो pole है ही नहीं. So there is no point about order. Now again use the expansion. Now dear, again use the expansion. Okay, we have sin z by z, na? Okay, that is 1 by z minus z cube by factorial 3 plus z power 5 by factorial 5, etc. Okay, divide by z. So what is fz? Divide by z, you get 1 minus z square by factorial 3 plus z power 4 by factorial 5 till infinity. Is there any principal part? All are positive power of z. Okay, this contains only analytic part. Okay, basically when you look from the expansion point of view also, there is no principal part. Okay, and that is the concept of removable singularity. ऐसा लग रहा है कि वो singularity है, but that is actually not a singularity. This is removable singularity. Clear? This is the concept of removable singularity. You should be aware about this. I know students are mostly confused about this. What is isolated singularity, removable singularity, essential singularity, and pole of order m. These are the 4 cases you must know. ठीक है? So यही तो मैंने बोला था. कहाँ गया? If the principal part does not exist, okay, okay, then the singular point is a removable singularity. Okay, then that is a removable singularity. Clear about this also now? Okay, ji. So be clear, sin z upon z cube, it is a pole of order 2. अब इसको shortcut से कैसे बोलेंगे? भाई ये तो इसका explanation हो गया. Okay, ये तो इसका detailed method हो गया. Okay, the definition of order is actually coming up from the expansion, from the power series expansion. Shortcut से इतना सा है dear. Shortcut इतना सा है. My function fz na, that is sin z upon z cube. So let me write it as sin z upon z square. Basically, one of the z will not contribute to the pole because sin z upon z is finite, na? Sin z upon z is finite. ठीक है? In my telegram Shakti, sin z upon z is finite. Okay, this gives you a finite result. अभी हमने देखा ना? This gives you a finite result. Limit z tending to 0, sin z by z. Okay, that gives you a finite result. Okay, so one of the z, कहाँ गया? One of the z shifted to the numerator, that does not contribute to the pole. I can say that there is only z square in the denominator. ये rough method है. Okay, okay, z square equal to 0. Z square is the term in denominator. That is the pole of order 2. That is a pole of order 2. But the actual method is this one. This is the actual way to define the order of the pole. This is the actual way to define the order of the pole. Just a second. Okay. That is the actual way to define the order of the pole. Okay. Now let us come back. Okay. So what I have also defined for you is what is essential singularity. Okay. What is essential singularity? Okay. Now what is the residue for the essential singularity? Okay, so if you have essential singularity, then the residue, I'm not deriving it again, not needed to derive, but the residue at z equal to z naught is given by the coefficient of 1 upon z minus z naught in the power series expansion. ठीक है? अब यहाँ पे हमें ये समझ में आ गया, Okay, that z equal to 0 was a singular point. Okay, and what type of singular point? Essential singularity it is, because the principal part contains infinite number of terms. Okay, so here z equal to 0 is an essential singularity. Here z equal to 0 is an essential singularity. Okay, so what is the residue? Okay, it is given by coefficient of 1 by z minus z naught. Z naught का value 0 है, with the coefficient of simply 1 by z in the power series expansion. That will be the residue directly, you can say. So what is the coefficient of 1 upon z? ये नहीं, complete after multiplying by z square. What is the coefficient of 1 by z? ये रहा z inverse term. Z inverse is 1 by z. So what is the coefficient of it? 1 upon 3 factorial. 1 upon 3 factorial. ठीक है? So the coefficient is 1 upon 3 factorial, and that is 1 by 6. Okay, so what is the value of the integral? 2 pi I into the residue value. So answer will be 2 pi I into 1 by 6, or after solving pi I by 3. Pi I by 3, option number C. Pi I by 3, option number C. ये सारे unique cases पता होने चाहिए. You never know which question lands up in your examination. You should know about the singularities. You should know direct residue question, but you know the case like cos hyperbolic z when the terms do not cancel, or by chance you have an essential singularity, or by chance you have a pole of order m. The clear order of the pole must also be known to you. Okay, the clear order of the poles must also be known to you. ठीक है? ठीक है, चलो, okay, done है. So let's go here. The time is almost approaching 2 p.m. Let me tell you at least one more thing for today's class. Here it is. Okay, I'll give you as a homework only. It's a gate question. This will be a homework, but please pay attention. Okay, the contour C given below is on the complex plane z is equal to x plus iy, where I is under root minus 1. What is the value of the integral 1 upon pi I dz upon z square minus 1? So, देखो, first of all, let's look into the poles. I'll give you some hints and then you will solve as homework. Okay, the pole is z square minus 1 equal to 0, z square equal to 1, z equal to plus minus 1. Okay, both are inside. Z equal to plus minus 1, both are inside. Okay, but the difference is, please look into z equal to 1. Okay, look into the curve around it. What direction? What direction? Anti-clockwise. Okay, what direction? Anti-clockwise. Okay, z equal to 1 is enclosed, it is inside and it is enclosed in the anti-clockwise sense. Anti-clockwise bole to positive sense. Okay, what about z equal to minus 1, dear? Okay, when you look into the arrow, when you look into the movement of this plot around z equal to minus 1, that is enclosed in what direction? This one is enclosed in the clockwise direction. Clear? This one is enclosed in the clockwise direction. Now some of you were asking, what about clockwise sense? Acha, if no diagram was given, like normally circle ka definition tha, so what direction I was assuming till now? By default I was assuming anti-clockwise. By default I was assuming anti-clockwise. If the path is not given to you, so by default you will take the anti-clockwise like circle based question. But there are two parts of this closed contour. Okay, one of them is traversing the pole in the anti-clockwise sense, one of them is traversing the another pole in the clockwise sense. Okay, so what is the integral answer? Acha, dono inside hai. Dono inside hai. So both the residues will be calculated. So answer of the integral will be, dear, 2 pi I. Please notice that. Okay, there will be the residue due to z equal to 1. Normally what we do, summation of residues. Okay, the residue of z equal to 1. Okay, in the positive direction. Okay, plus the residue of z equal to minus 1. Because it is in the clockwise sense, take the negative sign. Okay, negative of the residue for z equal to minus 1. So here I don't need to change any methods. You calculate the residue first as it is. Both are simple poles. Very simple question. Calculate the residue as it is. But second wale mein minus put kar dena. Okay, whenever any pole is traveled in the clockwise sense, take the negative sign in the final answer. Are you getting it? Are you getting it? Okay, that is the only difference. Residue calculation, very simple. Please try up as a homework and complete this. Okay, complete this. So time is almost nearing 3 hours. Okay, so I shall stop for today. But all important cases majorly I have done. But there are some cases not that important, but I suggest you to go through if you are not clear with the basic complex number theory. Okay, sometimes they ask very basics about complex number, like under root of complex number, yeah, magnitude phase of complex number. That is very basic. So I did not feel the need to cover it today. That is very basics. I hope you must be knowing it. I directly started with the function of complex variable. Even the title of the class is function of complex variable, but this is a suggestion. Okay, this suggestion. Okay, Lorentz series, already I have given you hints about the power series expansion. Okay, and third, solution of improper integral using method of residues. Okay, this is a suggestion. Okay, this is a suggestion. Okay, now, password for today's PDF will be residue. The password for today's PDF will be residue. I'll just share you the link of my Telegram. Yeah. In case you're not connected to me in the Telegram, but yeah, still I believe if anybody has not done anything in the complex function also, this session will be very much sufficient for you. Okay, provided if you want, not compulsorily, but if you want, you can put some extra efforts. It will take very less time. Okay, especially isko dekh lena. Okay, complex number basics you must be knowing. Lorentz series, even if you don't read it directly, it's okay, because concepts related around it. Okay, why do we normally want to study Lorentz series? Direct question will not come, but that singularity, that I've explained anyways. Essential singularity, removable singularity, all this I've explained. Ek baar isko go through kar lena. Just one question also if you go through, na, it will be sufficient for you. Okay. Here even if I take one question, explaining it will take time, and I think it's almost 3 hours and I have other classes and meetings to attend. So I'll stop here for today. I thought ki ye ho jayega, but no problem. That is suggestion. At least focus on this third part. Even one question you go through, na, sufficient for you. Okay. Rest, the PDF will be shared with the password, that is residue. Okay guys, that's it from my side for today's class. Okay. Alright guys, so in case you or your friends or juniors are planning to prepare for GATE 25 and 26, the Vision GATE 25 and 26 for both the years, both the different courses are available on the app in English as well as the Hindi format. Okay, so you can choose the language of your comfort. Okay, you'll have live classes, recorded lectures, study material, mock tests, practice quizzes, everything, just everything to get your exam ready. Okay guys, so if you have any queries regarding to the course, that is the timing, fees, faculty, anything you want to know, you can just contact 924-133-666 to get all your doubts rectified. Okay ji, Telegram ka link मैंने already share कर दिया. That's it guys, bye bye. Sure, Gautam, we can plan around it. But for linear algebra, I've taken some sessions, not one complete one, but discrete. Like 2-3 parts में लिया हुआ है, तो by the time you can refer to that also, you will find my videos on rank, you will find my videos on eigenvalue and eigenvectors like this, so that you can cover linear algebra from there as well. Linear system of equation पे separate मिल जाएगा आपको. Chalo guys, bye bye. Thank you. Hope you enjoyed this one complete short complex function session. Stay safe and take care of yourself.